Grafer finns överallt.
Graphs are everywhere.
Graphen sind überall.
Alright, graphs are everywhere, ain't they?
Los grafos están en todas partes.
图无处不在.
Grafy są wszędzie.
Grafikler her yerde.
Graphs हर जगह हैं.
גרפים הם בכל מקום.
Grafi su wszędzie.
I grafi no padu.
I grafi sono ovunque.
Grafikler her yerde.
Grafen sind überall.
Grafen är givande. Graphs har jagä här.
Graphs berada di mana-mana.
Grafen zijn overal.
Grafen sind überall.
Graphs are everywhere.
Grafike je všude. Graflu prati chota unnai.
Grafer finns överallt.
Grafen sind überall.
I grafi in padu.
Grafoች በየተመላ.
Графак легко густиетан daude.
Графовые решения повсюду.
Jitte gitte graphs ein.
Grafer overalt.
Tu wozu gut sei.
Hey, Grafen sind allgegenwärtig.
Graphs ella இடத்துலயும் இருக்கு.
Grafi so všude.
I grafici sono dappertutto.
Les graphes sont partout.
Графите са навсякъде.
頭無處不在.
Os grafos estão em todo lado.
Les graphes sont partout.
És grafikonak mindenhol vannak.
Le grafici tutte sono.
Grafen sind überall.
Los grafos están
En todas partes.
Graphs har jagä.
Grafos hay en todas partes. Graphs are everywhere. Really? Are graphs everywhere? Yes, indeed. Graphs really are everywhere, and Cypher is used to query them.
Hello, everybody. Welcome. Happy Global Graph Celebration Day.
Exactly. Happy Global Graph Celebration Day. Good morning, good afternoon, good evening to all of you, wherever you are on this great day.
Exactly. So we love to do these streams, and this is a long stream, so maybe we get to do this a few times during the session. But let us know, where are you? Where in the world are you watching us today? So let's have a look at what we've got. So we had a few pop up. So you know what? I love this feature. So let's do this. So we have got Bangalore in India. Hello, Vinny. Good afternoon.
Hi, Vinny.
We have got Mackenzie, you are in Victoria, in VA, so in the US. Good morning.
Yeah, good morning. Exactly. Is that early now? I don't know. I mean, time zones confuse me every time I'm thinking about them. But is that early for you or no? I don't know. Maybe not.
We'll find out.
We find out. Yeah, let us know how early it is, or not. Maybe it's just regular.
This is when my US geography just falls apart.
Yeah.
Okay, we've got Kin Barney in Sydney, Australia. Hello.
That is definitely early.
Yes, no, absolutely. Yeah. We have got we've got Krakow, Poland. Hello, good afternoon. Kultula. We have got Seattle, very early morning. I know as much as that Seattle's to the west of the US rather than to the other sides. But hello, good morning. We've got Senegal. We have got Casablanca in Morocco. Oh, another Seattle. Oh my goodness. We have got Thailand. Hello, Santipong. Thank you for joining us. We have got Ireland. So really, welcome. We have got Tel Aviv as well in Israel. So we have got a wonderful, a lovely.
That is a very global, yeah, exactly. Very,
love it.
From all over the place, really. That's great. That's really good.
Absolutely. Yeah. It is absolutely fantastic. Welcome, everybody. So we're going to get started shortly. So let's get this going. So I'm just going to, got everybody on? Okay, perfect. So very quickly, we've got a Discord. We've got a brand new Discord server. So come along. You've got the link there. We'll pop the links on as we go on during the day. We're going to quickly, we're going to put a couple more shout outs before we get started. So we've got Taiwan. So Michelle, hello. Yes. And Rashama from New York's in. Good morning. There we go. Right one. Good morning. Rashama's in as well and from New York. So there you go. Brilliant. Truly global attendance here. Fantastic. Welcome. So let's have a look at what we're going to be doing today.
Yeah.
So stream schedule. So all timings are approximate. So we've got a 3-hour show today. So in this hour, we're going to be doing a quick overview of what Global Graph Celebration Day is. We're going to do a bit of history as well around the graphs and Leonhard Euler. We're then going to cover a view of a developer journey with Neo4j. So we spend a lot of time talking about what is a graph and that kind of thing. But we thought it'd be nice to talk a bit about, depending on where you are, whether you're completely brand new to graph databases, whether you've got a bit more experience, what kind of things have you got available to you? And then for a bit of fun, bit of interactivity, we have a quiz. So we're going to give you an overview about the quiz. And then the next hour, we are going to have a community conversation. So we are going to be talking to 4 members of the community, and we're going to find out all about how they got started with graphs, what projects they're working on, what do graphs mean to them, and so forth. And then in the last hour of this stream, we are going to be doing live, as GraphQL library is now in beta. We are going to be having one of the regular GraphQL community meetings, but it's going to be open to everybody. So everyone can come and watch as an opportunity for any questions that you've got coming up. And then at the very end, and you're going to want to keep involved with this, we have got a very, very exciting announcement. So, yes, watch this space. Right. Okay.
That's cool. So, can I just say before we dive in how cool that intro video was? I like it so much. I mean, that's basically all of the Neo4j staff basically took some time and recorded everybody from wherever. I mean, obviously everybody is at home now, so wherever they sit and then home office style, different setups. Some outside, some in their home offices, and it's such a cool video, and it shows the company spirit quite well, I think. And everybody is invited, obviously, to do your own video like this if you like. Share it with us. Share it on Twitter. Mention us, so we'll watch that if you up for it. If you wanna, I'll post a video link from YouTube in the channel quickly after. But if we, if you wanna share the video in itself, you're always happy to do so as well.
Yeah, no, I love that. So yes, if you fancy saying graphs are everywhere in your native language and you're going, hang on a minute, that wasn't in that video, please let us know. We'd love it. We'd love it. So that would be amazing. Absolutely amazing. Right. So Alex, would you like to tell us a little bit about what Global Graph Celebration Day is?
Yeah, sure, I can. I mean, I think we established this day 2 years ago,
yes,
where we did the first global celebration of Leonhard Euler. Leonhard Euler is sort of the inventor of the graph theory. He was born on this day, so on the 15th of April, 314 years ago. So quite a long while ago. And we celebrate this day kind of because, obviously graphs are everywhere, and Neo4j is a graph database. So it makes a lot of sense for us to hold back on him and get him, thank him for inventing basically our technology, which makes Neo4j possible, or graph databases possible in general. And yeah, this is basically to remind us all of that and to celebrate this great invention that brings our community together.
Absolutely. Yeah. So for those of you who probably have done Global Graph Celebration Day before, it is a little bit different this year. So normally what would happen is we would encourage you to go and hold parties, maybe host meetups, and we have these events happening all around the world. And I've seen some really amazing things. Like I've seen pictures of cakes of like the 7 bridges and that kind of thing, which is really, really cool. So that's normally, you know, that kind of thing would be happening. Obviously, given the current situation we're finding ourselves in, that's not possible. So we decided, yeah, so we still want to mark the day, and we thought, hey, let's do this. So like this, we've got an extended stream. We've got people from around the world watching, which is amazing. And we've got different ways that you can get interactive and still join in and be part of the day. So as we mentioned before, we are now on Discord. So some of you may have been on our old user Slack. So we've now moving over to Discord. We have a channel in there. So go have a chat, either chat with people you know already in the community, come meet new people. If you're completely new, welcome, come joining. We'd love to hear everything about you. So we've got our chat server there. If you are working on a project, if you're working on something of interest, doing some theory, anything like that, and you want to talk about it and have a discussion, we have got our forum. So that's community.nefj.com, and that's a great place to have these lengthy conversations, or maybe you want to have a discussion about a data model that you're doing, or get advice, hints and tips. That's a great place to go. And we'll touch on the quiz a little bit more, but this is another opportunity for you all to get involved, and that is to have a go at this quiz. So it's a bit of fun. We have some prizes, so don't be rushing off now to do the quiz. I just imagine now everybody's going, right, quick quiz. We're going to cover the quiz in a bit. Don't worry, you have plenty of time to complete the quiz. So, I was looking at and sort of thinking about the kinds of things that Euler done, and I just. You know, you may remember him. I thought, oh, yes, Troy McClure from The Simpsons. I couldn't help myself. I had to have a picture in there. So, you may remember Leonhard Euler from such works as mathematical notations. Now, I cast your minds back, and I think we had a bit of a pre-show discussion about math versus maths. But cast your minds back to when you last did maths. And some of these symbols you may remember, and these are all primarily being driven by Euler. So, for example, he started this idea of having this concept of a function in mathematics and representing a function or a function of x in this example using this notation. The I, imaginary numbers, again, another thing that Euler gave us. So this idea of being able to represent complex numbers. The sigma, so a way of being able to represent the summation of things. Again, another notation that had been pushed by Euler. E, so otherwise known as Euler's number, also the logarithm base of a natural logarithm as well. Again, another contribution. And this one tickled me as well. So you know when you're working with triangles, do you remember trigonometry? I love trigonometry, by the way. I know it could be hot and cold, but you know how you represent the angles. You represent the angles of your triangle with a little a, little b, little c, and you represent the size of the lengths of your triangle with a capital A, B, and C. Again, another one from Euler. So that's cool. I'm loving the shout outs here. The love of maths. Yes, maths is great, isn't it? Another thing that Euler gave us was the Euler's identity. So this is the idea of e to the power of I times pi is equal to -1. And this is something that is really useful in the sense of being able to represent complex numbers in planes, as well as demonstrating the relationship between e, I, and pi. So again, another big give here. Euler's diagrams. This is very, very pertinent to what we're covering here. So the idea of being able to represent relationships between data as well as the sets. So that's another one. last but not least, oh no, there were many more contributions, by the way. So the one that we're highlighting today will be graph theory, which is obviously going to be the whole emphasis of this show. But he's also made contributions in calculus and so many other fields of mathematics. He had a prolific space within mathematics. And as Alex mentioned earlier, so something that Euler did, so he didn't start the usage of the Greek symbol pi to represent that value. He popularized it. So I think there was a Belgian person, I think, who actually started this, but he really popularized the use of this symbol in equations. And Alex mentioned earlier, today would have been Euler's 314th birthday. I know it's only going to happen this year, but it's still cool.
It's so cool.
So cool.
Yeah. I mean, you have, I mean, if you do only one of these things you just mentioned before, the notations, the Euler's identity, the diagram, and on top of all of it, the graph theory, you would have been, you know, a famous person of its own. But he did all of those together and more. It just shows how much of a genius he was, really, because, I mean, this is amazing.
Oh, absolutely. Absolutely. So I guess let's talk about, where did the graphy story begin? So the history, the 7 bridges of Königsberg. So it is a place now in modern day Russia, Kaliningrad. So for those of you who were watching the World Cup when it was being hosted by Russia a couple of years ago, I can't remember, was it 3-4 years ago? A lot of the matches were played here, but it was then in Prussia. And just to describe a little bit about this town, you had the 2 mainlands, you know, 2 bits of the city that were split by the river Pregel. And on there as well, there were 2 islands. So we had the Lomse Island and the, this is good. I'm going to let the German pronounce this.
Kneiphof.
There we go. Kneiphof and Lomse on the River Pregel. And so you had these 4 land masses. And you had these bridges that were connecting the different land masses together. So 7 of them, to be precise. And this turned up in a newspaper as a maths problem. And the question that was posed about this maths problem was, is it possible, what would the route be to allow you to visit all 4 of these land masses using the 7 bridges? But the trick here being, you have to use all of the bridges, and you can only use the bridges once and only once. And Euler came across this maths problem. Obviously took interest in it. And what he recognized from this, when he was coming to pull together the way you'd go around trying to determine whether this problem was solvable, was recognizing that the route that you took was not important. And the key things here were to do things such as simplifying the problem to abstract terms. And thus, graph theory was born. And he also proved that this problem has no solution as well. So, Alex, what is a graph then?
What is a graph? It's a good question. So I think we see lots of graphs in the world, and some of these are mistakenly called graphs because they actually are charts. But and this is like also a language problem in German. These are both of them actually have the same word to it. In English there is a different word, but people mix them up. But a graph consists, as we see it, basically of nodes and relationships. So like here in this depiction here on the right hand side, you would see a graph with the blue dots being individual nodes, and the black lines in between these nodes are the relationships that consists of the graph. And it has various types of ways you can show a graph. This is a fairly simple one. They can go very complex and very elaborate and huge interlinked data sets which show different kinds of things, which I guess we go into later on. But it's a very powerful visualization.
Absolutely.
For
And very quickly, just to sort of touch back to Königsberg, what Euler effectively did was take the land masses and the bridges. And he said, well, actually, you know what? These land masses, these are these discrete entities. So we'll treat them as discrete entities. And the bridges are these relationships that are describing how these discrete entities are being connected together. And this is an example of the abstraction that he did to take the problem of the 7 bridges and turn it into this abstract view to then go off and solve the problem. So we're not going to spend a huge amount of time on defining what a graph database is. I suspect many people here watching today already know. So very briefly, we've talked about what a graph is. So a graph database takes on this idea of having these discrete entities and describing how they're related, how they're connected to each other. And what a graph database does is it takes that principle and stores data. And what it says that the data entities that we have, the relationships that connect those data entities, those are just as important. They have equal importance as the entities themselves. And that allows us to do a lot of things to understand how things are connected. And because we have this equal importance attributed to the relationship as well as the entities that are connecting them in a native graph database, how we store those, how we reflect those, everything's changed so that we have this interesting system that we can work with. So we're not going to go into a huge amount of detail about how graph databases work. If you are completely brand new and you're tuning in, welcome. What I suggest you do, and we'll post a link in the chat, we have a quick link there, which is just a short page on what is a graph database. So we'll drop the link in that's available for you to look at if you're new. And also we will have details as well with regards to what to do if you are brand new. So we're going to touch on your developer journey with Neo4j. So we have this road reflecting the different stages where people are on their journey. And we have 4 graphistas. We have Dan and Anne, Zane and Jane. So,
and by coincidence, total coincidence, these names are rhyming.
I like my rhyming and I like my alliteration. What can I say? So, okay, getting started. So let's meet Dan. So Dan is completely new to graph databases, and he's pretty new to software development too. So what would you do as an absolute beginner? So absolutely, I know a lot of people probably here have got a developer background, but sometimes you want to talk about graphs to your colleagues, to your friends, to your family, and they go, this is exciting, but I can't do anything. Yes, you can. There are many things you can do to have a go and work with graphs and query with them and explore them without having a developer background. So what might this look like? So you've got an option here, which is the sandbox. So tell us more about the sandbox.
Well, the sandbox is a great way to start. I think it's an easy way to start. You don't have to download anything. You don't have to prepare anything. You just go to neo4j.com/sandbox and you start your own sandbox. We have a couple of them ready for you. So they come with preloaded data. So you can pick whatever a topic is interesting for you. There are obviously blank ones which you can populate yourselves, but there are ones with preloaded data on fraud, with product recommendations, the movie graph set you might have come across already before, which we use for recommendations and social networking between persons. There's a product specific one in there which shows you customers buying products and other customers buying also products and stuff like that, and how our inventory management kind of system would work. So these are many, and they come with little guides, little tools how to do stuff, how to explore the data, you don't even have to write the queries at first yourself, so you can just click on something we have provided for you, so you really see what the power of Cypher is and what the power of graphs is, and without you knowing all of it yet. So you can easily start there and learn. If you wanna learn I don't know, before or afterwards, if you want to dig deeper, you can always also go to our Graph Academy pages, which is like a tutorial setup.
Yeah. So just as Alex said, this is a really great way that you've got options where you've got pre-canned data, the queries already been written, and just as an example here, so this is one we've got on the Panama Papers, you will have a data model, so that'll describe to you what the data looks like. You've got this walkthrough guide, so it's explaining what's happening in this use case. So it's a really nice experience where you can navigate through and get comfortable. So you don't literally spin it up, no download, no install. It's a really comfortable way to learn with graphs. Okay, so we've got Dan. So Dan was new to graphs and new to software development. We've got Anne now. So Anne is a software developer and she's new to graphs. So she's come across graphs and she wants to learn more. So the sandbox is also really helpful for Anne. So again, the powerful thing about this, you don't need to download anything, you don't need to install anything. You've got pre-canned data there available. You also have an option to have a blank database. So if you want to bring in your own data and play, you have that option there as well. And what you have available on the sandbox is you have these code snippets that show you how to get up and running in your chosen language. So we have these language APIs. You can pick which one you're using, and you even have instructions about how to install the driver into your environment, into your IDE, as well as a link to documentation. So for example, here you see it'll give you all the information with regards to that sandbox, so the password, the address, a snippet to bring back some data and so forth. So this is a nice way to get up and running really, really quickly in your IDE of choice. So we've talked a bit about how do you get your hands dirty. So where do we get more information with regards to this? So it's great. You can click through and look at some examples, but probably want a bit more information. So got Dan. So Dan's excited. He's looked at the visualizations. He wants to learn more about graph databases. Jane sees it as a useful introduction, but she probably wants to move at some point beyond the sandbox and wants to do some more interesting things. So we have a number of options here. So we've got the Graph Academy. So a little bit more about the Graph Academy.
Yeah, the Graph Academy is a place where we have collected a couple of tutorials. So I think they are varying from intro level kind of tutorial where we really go to the basics, a little bit what we explained here, but obviously in more detail, where we show what's what and what is a graph and how to get going. But then they go deeper. We show how you do data modeling, how your graph model would look like. We would explain you how to do that, and then how to set up your first graph project. And then it goes even further than that with the graph data science modules, where we show you how to use our algorithms that come with the graph data science module. So it's a wide variety, and I think it's fit for everybody, no matter what kind of level you are and what stage you're in. You should find something that is relevant for you. And should you be really advanced, you can also go there and get certified as a Neo4j certified developer and take a test, and that will give you then a little badge which you can put on your LinkedIn profile or Twitter.
So another resource we have as well is the developer pages. So we're going to have all of the links coming at the end. Don't panic. We have the developer resources. So if you go to neo4j.com/developer, you have a lot of information there with regards to links to various things, as well as documentation, walkthrough guides, and so forth. So you get an example here. So this is one of the developer guides that we have, which is getting started with Neo4j. So we have got a lot of content there. So anything from what is a graph database, getting started with Neo4j, learning Cypher, which is our query language. You'll have examples of how to get started in your various drivers of choice, so your language APIs to get connected to the database and so forth. So you have a lot of content there as well.
Yeah, lots. So it's really a huge repository for all kinds of information. So I would say if you don't find it there, it's probably not existing.
So you've got that content as well. And then we also have a YouTube channel. So for those of you who like to consume information via video, we have a lot of technical content available on our YouTube channel. So we have live streams happening on Twitch, much like this one, which will then appear on YouTube, and my colleagues Will and Florent and Michael and many others do a lot of technical videos. So you've probably seen some of Florent's videos on Spring, or for example, Will has been talking about building applications from the ground up. So building up a Realtor application and other full stack modern web application systems based on Neo4j. So there is a huge amount of content there as well. Check out the playlists if that's of interest. So that's a useful way to take that step beyond. So you've had that first hands-on experience of working with the database, and this is how you can start to build that knowledge and learn more about graphs. Doesn't always go to plan. Sometimes you need a little help. So there are a number of places where you can get help. So first is I think let's go through them. So you've got the community forum, the Discord server, and Stack Overflow. So given Discord server is quite new, would you like to tell us a little bit more about it? And
absolutely, yeah. So I mean, maybe a little bit about the story. So we used to have a Slack channel, user Slack, where we had the opportunity to interact with the community basically on a one-to-one or an individual chat basis, like real-time sort of, and that was a little bit full and had a problem of deleting old messages. So it was kind of sad to see that some people answer questions and they took really lots of time and give good help and advice, and then to know that after a couple of weeks this answer would go away forever and then nobody would be able to see it anymore. So we looked out and said, okay, what can we do? How can we find a new place for the community where it can be engaging, where everybody can chat, the Neo4j folks, the community folks, basically everybody who wants to. And we decided, hey, let's go to Discord, and we opened up this Discord server, which is now open and everybody can join, and it's growing. So coincidentally, also this week we crossed 500 members there. So I think that this Global Graph Celebration Day stream is a general community celebration stream, because it's a great milestone to achieve after so little time. And yeah, we welcome everybody. Join, see what's what. Chat to everybody in the community, chat especially to Neo4j folks if you like. We are here for you, and we look out. And I think it's a fun place, and it's growing, and we have good ideas what to do with it next and what kind of activities we are going to run with the community on there. So yeah, would be happy to see you all there.
And let us know your ideas. So we've got a suggestions channel there. So if you've got things you'd like to see, so just as an example, we've got like a learning class. So if you want to do the Graph Academy and you want to do it with other people, our colleague Andreas is setting together times where they go through all the class material, and there's loads of other things going on there. So if there's something you want to see, let us know. Do let us know.
Yeah.
For situations where you want to have a bit more of a discussion, let's say you want to put up a data model and you want to have something that lasts some time. So you have a discussion that lasts for a period of time, like days, weeks, months, that kind of thing. We also have the community forum. So that's our discourse community forum. So there is a great place to discuss any project ideas that you have, sort of look at queries, best practices. We have our knowledge base on there. So that's another really great place to get some information, as well as ask for help. And typically, if there's a question, it's probably turned up on Stack Overflow at some point. So that's usually a good place as well to check to see any solutions that people have asked. So that's really great for those sort of short questions like, I am getting this error, what do I do? Or my query doesn't run, and you discover there's something missing there. So obviously you've got the various places where you might find assistance.
Exactly, especially in these early stages. I think all these questions you might have probably have been already asked and answered. So yeah, you will probably, if you stumble across something and say, oh, this is not right, why do I get this error here? Just type it into Google or Stack Overflow right away, and you probably find a ticket where this was dealt with.
Yeah, absolutely. So, okay, we've got Anne and Dan, and they've gone through this journey. They've done the hands-on stuff. They've signed up to the Graph Academy courses and they've completed those. So let's start thinking about getting comfortable. So we've got Zane, and Zane is a software developer and he's got some experience with Neo4j. So he's gone through this process. He's done some of the courses. He is working on a graph-based project. Maybe that could be work. It could be a side project that he's working on in the evenings because he's discovered that Graph's going to help scratch a problem itch that he has that he's always wanted to look at. So we talked about the sandbox as a great starting place, but something to bear in mind is that it only lasts up to 10 days. So by default, you have 3 days and then you can extend it up to 10. And whilst you can have as many sandboxes as you like, a sandbox can only live up to a maximum of 10 days before you need to create a new one. So an option you can use is try and run something local in your machine. So one option we have is the Neo4j desktop. So if you go onto the website and you'll find the download button, on there you will be able to download Neo4j desktop, which is a developer aid, and that allows you to manage a number of databases as well as graph apps there. And that allows you to either create and run a database local on your machine, or it allows you to connect to a remote database someplace else. Another option you have is you may decide, well, actually, I don't need the Neo4j desktop. I'm quite happy to manage the instance myself. So what you can do is you can download the server version of the product and you can run that either in a console or as a service in your machine. So that's another option as well. That's perhaps more for advanced users who are comfortable and looking to deploy. And the third option is Neo4j Aura. So Neo4j Aura is our database as a service offering. So that's in the cloud. And more excitingly, we have an Aura free waitlist. So would you like to tell us a bit more about Aura free?
Yeah, I mean that's upcoming. So we have a like you said, we have a waitlist ready. So Aura is basically a graph database in the cloud, our service we introduced 2 months ago, I want to say, earlier this year for sure, with a launch that is now available on Google Cloud Platform and will be later on AWS and Azure in 2021, so later this year. And it's basically like I said, a graph database as a service offering. So you don't have to worry about anything of the maintaining of the how to set it up, how to do whatever. You just click a button and it spins up for you, and you can work on there. So it's very easy, very simple, and like you said, Lou, we will be offering a free tier later this year, and you can subscribe now for the waitlist. Where you then have the opportunity to do exactly what you were able to do on Sandbox, but for basically unlimited time, and you don't have to worry that it's going to be closed off on you. So that's going to be exciting and great.
Yes, and keep watching at the end. The special announcement. Keep watching.
Ooh, was that a teaser maybe?
Don't know.
No, who knows?
So you've got Anne, Dan, and Zane, and they've spent a lot of time learning about graph databases and how to query them and where they're good to use and where they're not so good to use. And perhaps now it's time to have some recognition for this. So I've just got a quick question about the free tier. We'll give you the link for that. Watch this space. So how do we get some recognition for the time they've spent? And we have, as Alex mentioned earlier, the Neo4j certified professional, certified professional developer. So tell us a little bit more about the certification and the process.
Yeah, that's a that's a great tool to show that you are really a professional Neo4j user, and you know your things around the graph database and Cypher. So in order to get certified, you need to go to the Graph Academy. We'll share the links with you also in a moment. But there is a button that says Get Certified, and from there you need to run a test. It's around 60 minutes or so with a good amount of questions. I mean, depending on how quickly you are on answering these questions, but roughly the estimate is that it takes you 60 minutes to complete. It's not easy. So you need to be aware that this is not something you can do after you do the intro training and then you think, oh yeah, it's fine, I can do it. No, it really goes into detail, and we have also a couple of different versions. So you can do a data science edition and you can do a regular edition. So depending on what you want to do, you can do either. And yeah, once you complete it, you get a little badge of honor, and then you can put it out and say, "Hey, I'm actually certified, and we approve of your skill."
Absolutely. So, last but not least, let's introduce Jane. So, Jane is a seasoned Neo4j user. She totally is mastering Cypher. She did queries, she's done lots of projects, she's very, very comfortable. So what's available for an expert user? How do you push the boundaries? Well, maybe something worth considering if you've not done so already is have a go at building your own user-defined procedure. So what you have available in Neo4j is the opportunity to fine-tune and build specific functions. So much like you may use some of the APOC functions or the graph data science functions, you also have the opportunity to build your own as well. And this is a really great way to maximize the performance out of any queries that you're running. And it's a good challenge. So it's a good way to test your knowledge. And if you ever have that, I wish I could do X, well, this is a great way to just learn and experiment with that. Another option as well is really get comfortable with APOC. So APOC has something like 500 plus different functions and procedures. So it's one of the libraries that we have. And there is a lot of amazing functionality in there that will allow you to really maximize the performance out of your queries and what you do from the database. So getting really comfortable, and there's a lot of functions in there, such as being able to be very specific about how you query your paths, whether you go breadth first or depth first within queries, using virtual nodes and relationships, and so much more. So become an APOC pro. Again, it's a really good way to build up that knowledge and think about how you can use that library to improve and boost the performance of your queries. And another one as well is check out our blog posts. So we have a developer blog post site. So on Medium as well as a new one we're setting up on the Neo4j website. And we have a lot of introduction content there, but we have a lot of advanced stuff on there as well. So use it as an opportunity to look at some of the projects that people are doing and get ideas from that and see sort of what inspiration you can get from that. And last but not least, getting involved. So a real big shout out to our community. And we have so many community members that do a lot of amazing things and help each other help each other out as we're using Neo4j, as well as showing how you're using the projects and building tools. And we're going to be talking to our community members shortly. But if you're thinking about what can you do to get more involved, there's lots of different things that you can do. So if you've built a project, so if you are a Java developer or using Python, if you're working in a full stack space or anything like that, you're working in DevOps, you're working in whatever, and you've been using Neo4j, why not give a talk about it? So is there a local meetup group you can go to and talk about how you've used it, what works well, how did you put stuff together? Do that. That's really, really, really cool way to do things.
Yeah, and then lots of these meetups are now available online. Basically, they do online streaming, they do live events, because obviously you cannot meet in person. And this even makes it possible to join a meetup group where you are not close to physically. So, I mean, obviously, try to if you want to join something that is local to you, that makes sense. But sometimes it's just still an hour or two away, so too far away maybe for a half an hour talk. But and you can do it from your home. This doesn't matter anymore. This is great, and you can interact with the community in this way.
Absolutely. And again, if you're building something, and we also host meetups, so if there's a project that you're working on, you're working on a community driver or something like that, let us know. We can, we're always happy to share these stories. We really enjoy it. Another option as well is maybe write about it. So you've built something, why not put together a blog post about it? And it's a really great way of also demonstrating the skills that you're building around graph databases, but it's also useful for other members of the community so they can understand if you've learned something. So is it best practice? Is it an experience? Are you putting together different technologies and you've built something exciting? Write about it and let us know, because we would love to plug your work. So if you've put something together, give us a shout. We love to promote that, and we do that in our weekly newsletter. We do that over Twitter and so forth. So if you do write something, let us know. Another thing you can do as well is present. So we have our conferences. So we have Graph Connect and Nodes. There's a couple of the conferences that we do at Neo4j, but talk to other external conferences as well. So if you've built something cool, let the world know. And this is a really, again, great, very much similar to writing blog posts at Meetup. It's a great way of building up your brand, but also sharing the amazing work you're doing with the community. And we've got a shot here of Luann, who was presenting at Graph Connect, and she will be with us in about 10-ish, 15 minutes. So we'll be able to talk to her about some of the conferences she's been doing and some of the ideas she's come up with.
Yeah, that would be good.
Absolutely. And we also have the Neo4j Ninja program. So I've spotted we've got a few ninjas on the stream as well. So this is our ninja program where our ninjas come and help us and answer questions, and they use their Neo4j expertise to answer questions that come up in the forum. And also we provide advanced training for them as well, so to keep them up to skill and really improve, and help build that continual development of Cypher knowledge and graph knowledge in general. And I'm just going to do a quick shout out for Nathan Smith, who said he would love to hear your graph stories. So Nathan Smith runs the Kansas City Graph Database Meetup group. So he's posted the link in Twitch. We'll make sure we get that copied over onto Discord as well, Discord if you're watching there as well. So yes, reach out to Nathan if you would like to do your graph story at the Kansas City Database group, Graph Database Meetup group.
Yeah, and we had Nathan on stream before a couple of weeks ago, I think. So it was great. So he's nice, and if you if you look for some place to start your presenter journey, this is a good place to do that.
Absolutely. So, okay, let's talk about what we've got. So we're going to put all these links in the chat, and we'll have them in the YouTube video description after we finish the stream. So don't panic. So just quickly showing you these are the various links that we've got. And we're going to talk a bit about the quiz before we start bringing on our guests.
Just before you get ready, maybe I just wanted to shout out quickly to the community as a whole. I mean, it's just such a welcome place, and such a nice bunch of people really all over. So it's I never had anybody that was not helpful, that open, not really excited about somebody else sharing their graph story, sharing what they're working on. And then helpful to jump in and see, okay, hey, I can improve this, or do you need some help with this? And then everybody is really supportive on this. And no matter which channel we are talking now, is it Discord we just launched, or is it here on Twitch, or is it on the community forums, or on Twitter, or on Reddit, or Stack Overflow? So it's just such a nice place, and such a nice group of people. So yeah, I'm pretty sure no matter what you are, if you are just joining or if you are further along your journey, you will find friends even in this here.
Yeah, and as you say, Alex, our community really makes the whole experience. It really does. And it's such a wonderful group of people, and it truly amazes me the amount of involvement people do, how people help each other out, the amazing community projects that get built, the meetups that get put together, the amazing blog posts that I'm privileged to read and have a look at. It really, really is wonderful. And like you say, yeah, the community really, really makes it. And if you're new, welcome. Come say hello.
Yeah.
We're a friendly bunch. Right, so let's talk a little bit about the quiz. And it's a bit of fun. It's not mastermind, it's all good. So
that's good.
So it's a little bit of fun. And it's to give something that's a bit interactive. So at least we've done something that's a bit different. So we have a quiz. There's about 9 questions in there. So you've got until the end of April. So plenty of time. If you want to share the quiz, please do. You're welcome to. And we do have some prizes. So we have some T-shirts. And what we're going to do is we're going to be drawn at random, but we are going to do some correct answers. So please try and answer the questions. So yeah, it's a type form. It's really easy. It's like 2 minutes, a bit of fun. We have some silly questions in there. I was tempted to put some extra silly questions in there, but I resisted. But just a bit of fun in there and some useful stuff at the end. But do check out the quiz. So what we're going to do is we're going to move to a guest. But before we do that, I'm going to play that video game because I do think it's good fun. And for those of you going, hang on a minute, I don't have graphs are everywhere in my language. Let us, if you want to record one, we would love it.
Yep.
Right. So let's do this, and then we'll move into. Then we'll introduce our guests.
Exciting. See you.
Grafer finns överallt.
Graphs are everywhere.
Graphen sind überall.
Alright, graphs are everywhere, are they?
Los grafos están en todas partes.
图无处不在。
Grafy są wszędzie.
Grafikler her yerde.
Graphs हर जगह हैं.
גרפים הם בכל מקום.
Grafi su wszędzie.
I grafi no padu.
I grafi sono ovunque.
Grafikler her yerde.
Grafen sind überall.
Grafet är en givande. Graphs har jagä här.
Graphs berada di mana-mana.
Grafen zijn overal.
Grafen sind überall.
Graphs are everywhere.
Grafike je všude. Graflu prati chota unnai.
Grafer finns överallt.
Grafen sind überall.
I grafi in padu.
Grafoች በየተመላ.
Grafoak легкостиетен daude.
Графовые решения повсюду.
Jite kite graphs ein.
Grafer overalt.
To wozu gut sei.
Hey, Graphen sind allgegenwärtig.
Graphs ella இடத்துலயும் இருக்கு.
Grafi so všude.
I grafici sono dappertutto.
Les graphes sont partout.
Графите са навсякъде.
圖無處不在。
Os grafos estão em todo lado.
Les graphes sont partout.
És grafikonok mindenhol vannak.
Le grafici tutto basso.
Grafen sind überall.
Los grafos están
En todas partes.
Graphs har jagah hai.
Grafos hay en todas partes.
Graphs are everywhere. Really? Are graphs everywhere? Yes, indeed. Graphs really are everywhere, and Cypher is used to query them.
Welcome back, everybody. So we are super excited now to introduce our guests. So we're going to be we've got 4 guests, so we're going to be having 4 chats. And we are going to start with Shilpa Kokera first, who is CEO of Mara Technologies. So let's bring you on.
Hello.
Hello. Welcome.
Hello. Welcome.
Absolute pleasure.
It's so nice to have you. Thank you for joining us today, Shilka. That's great.
Thank you. And it was awesome to see graphs is everywhere. I mean, I can so relate to that. And I'm thrilled that we're celebrating it and the world needs to know, I mean, how we are all connected, right?
Yeah. Where are we having you today from? From where are you joining us today, basically? Yeah.
Currently, I'm in Mangalore, the beaches of Mangalore in India.
Oh, nice.
Yes.
You're sure of my envy, because here in Munich it has snowed a little bit this morning. So beaches of Mangalore sounds like a place I'd like to be.
Totally. I mean, totally welcome. And I think the graphs, I mean, connect us in digital ways. And I think that's the beauty of experiencing each other's worlds, right? I mean, from different corners of the world. Yeah.
Absolutely.
Yes.
So
over to you, Devika. Yes.
So tell us, what do graphs mean to you? How did you come across them?
I think we study data structures, in college, but when I stepped out after college, I saw the beauty of networks or social network in general. And though I'm here, I've met you all, I mean, known you all through technology, and I see the graph connecting each one of us. So we are all the nodes in the graph database, right? And the connection we have here is the relationship, and Neophurgy puts that up very nicely. So that's what it is for me, the digital representation of how we are all connected. I mean, we might not know it today, not know it tomorrow, but somewhere, 3rd degree, 4th degree, maybe, but we are all connected through 6 degrees of separation. So that's what graph is for me, and that's the beauty of it.
Yeah, that's great. That's nice. That I think that's one of the charms of graph. That's one of the, like I said before, or we said before, the community. I think this is really that makes it resonate so much with everybody. How did you discover Neo4j and graphs? How did you? I mean, you said in university, but was it a lecture, or did you then go about and say, hey, I want to know more? I go.
Yeah, I mean, I think that was Googling. I mean, college, I think we studied about graph as data structure, and there was a need for something to be stored in a graph structure, graph-like structure. And though there were many graph data, like there were certain, concepts of building graph databases earlier, but there wasn't a very visual format that I could find. And when I found it on, like, while Googling around, I think I've stuck to it from past couple of years, like 5-6 years at least. So I mean, that was my discovery, and the UX, of how it's actually represented makes it all the more powerful. So that's what I think makes me go back and work on it over the years. Yes.
Cool.
What would be really exciting to hear is, tell us about how you've been using them. So where have you been using graphs? Where have you found them useful?
So I think I've been onto 2 key initiatives from a couple of years. One is to make job opportunities accessible, explorable. You could discover different opportunities across the globe. So, that's where, for me, the graph database for me comes into picture for Jay. So, for example, I mean, I think I've spoken in one of our past talks in Nodes 2020, Jibika, that it's not necessary for one person to be the same profession as his parents, like from the medieval ages, right? Today anybody can be anything, and if we are stored, our data is stored in a graph database, the potential of discovery of somebody having some core competency that's common to 2-3 jobs, then you could have an opportunity that you might not have known as well. So that's one key initiative that I'm working on, that is to translating resumes and job opportunities onto graph databases so that the discovery of opportunities become better. And that's one of the key work that we've been doing over the years, and we plan to eventually make it open source, hopefully someday, where everybody can contribute to it and even create discovery algorithms. That's a dream as a techie here. So
that's super cool. That is very cool.
Yeah, like I think that should happen, right? I mean, everybody deserves an interesting job, and everybody deserves to have fun when they work, and technology should do that. So yes.
And I think it's great because also this comes back to the power of the graph. Basically, you see your standard CV. What do you have in mind? Some kind of table where somebody puts in skills, and then you say, I can I know programming languages and other skills. But this is just independent sitting there, and then where's the connection to other things? What you did, what projects you ran, and then all of a sudden, if you take it away from the table, it really connects.
Exactly. It's a pain point that a lot of people don't even get discovered because they didn't have a word in their resume, probably. Like, they didn't have Python or that one word, and probably they had the logic to do the job, but they would never be discovered. So that's I think the fun part, to make that discovery happen through graphs. Yes. And I have another initiative that's closer to my heart, is medical research. So I wanted to make sure, like in this COVID situation, it was quite hard to find all the clinical trials that's happening across the globe. And if you have a dear one who needs that last chance at some medical trial or clinical trial, the information is still not there, like to find out who has that clinical trial available right now. And even when you Google, it wouldn't have it because the information is all in research papers that's inside a publication or inside a PDF format, and that's why the discovery is again hard here. So I want to make an open repository of information which is accessible across the globe. And so basically your publications could be broken down into different information pieces and put down in different clusters of graph databases. So that's another vision, to make something happen in the medical research space.
So how do you approach that? How do you start pulling that kind of project together?
So we started aggregating things together first. So we are focusing on renal care at first. So we're trying to connect all the nephrologists across the globe, all the foundations across the globe, what every foundation excels in. So if there's a renal patient who requires a particular kind of profile, so somebody who's diabetic and has certain particular symptoms of neuropathy, and there's somebody who's doing those kind of trials and also trying to find that kind of patient, I'm very sure. And both need to match, right? And if this graph database connects these two, then that's the magic moment that we want to make it happen. So how we're doing it, we're aggregating it, and we're trying to create a lemma or a structure that creates a relationship or a possible relationship, and we are giving weightages to these relationships every day. So if the relationship is not correct, it penalizes itself. If the relationship strengthens, so if I've connected two people that don't know each other and they've actually started speaking, then it is rewarding the relationship. So that's what we are working on.
Oh, brilliant. That sounds really, really exciting. So, and it's all about these connections and bringing people together. And what I really find fascinating about a lot of these things is not to trivialize the implementation effort, but a lot of these ideas are quite simple and elegant, in the sense they're quite simple, but the fact that they're not there yet, and those opportunities to be able to bring these things together and bring value to so many groups is so powerful.
That's true. And community can make it happen. It's not that one person is going to make this happen. It's not possible. I mean, it's all of us who believe and who will make it happen. So there's hope, and there's these celebrations that give us hope to keep going. And I look forward to that as a community.
Absolutely. Absolutely. So I guess as a quick question, so what's going to get you excited? What's the thing that in the very near future that you're sort of getting you really excited and you're looking forward to around this? What's the sort of the key thing?
So I want to have this aggressive open source contribution across the globe. So today, when you checked on the people across the globe, it was a beautiful feeling, and I was part of it. So I feel that needs to increase like 10-fold, 1,000-fold, and the power is going to be huge in terms of human impact. So that's going to get me excited. So I look forward to a very high impact, high transaction rate of activities amongst the community, and we have to keep doing that actively. That's going to make me excited. So I look forward to that.
Fantastic. Thank you so much for joining us. Really appreciate it. And I'm totally excited. I really am looking forward to hearing both about the open source job. I'm going to call it the open source job detector. I know it's got a proper name, but just this idea. But it's so true, because you think about a lot of job searches are automated, and you have a bot that just basically scans a CV and he goes, nope, you don't have these keywords, therefore rejected. Yes. And you go, it's got to be smarter than that. It has to be smarter than that.
Exactly. Yeah. That's true. And then the second one is Usha Renal Care Foundation, based on my mom's name. So I hope that the foundation improves in medical research as well, because I think in these times it's much needed as well to enable that as technology.
Absolutely.
I mean, sorry, Lou.
No, go for it.
There's so much information out there, and it's just not easily accessible for everybody. It's not easily even visually clear for people to see and to access, and then it's so you just get buried in information and stuff, and it's not like I just need this one here, and where is it? And then you get
yes,
it's
lost.
Very hard. You get lost. Exactly. Yeah.
Exactly. That's what I hope for. The great future, and let's innovate.
Yeah.
Thank you.
Thank you very much.
No, absolutely. And we are really, really excited to hear about both initiatives, and love to hear about the progress in those, and decide that sort of the open sourcing things, the kind of thing the community just wants to dive in and help with. So absolutely look forward to hearing updates, and we'll keep everybody updated about what's happening with
where can people, just quickly, maybe where can people find you if they want to get in touch with you?
LinkedIn would be the ideal place. I'm active on LinkedIn. You can find me as Shilpa Kartera, and I'll be there. And I think, I'm pretty open and accessible. So please feel free to, and we can definitely do a lot of exciting things. So.
Perfect.
Fantastic. Well, thank you so much for joining us. We hope you have an amazing day, and please enjoy the rest of the celebrations.
Okay.
Thank you for joining.
Thank you. Bye-bye. Bye.
Okay, so that was very exciting. I know, super cool. Really, really exciting use cases and applications. And I just love this continuing theme of connectedness and just connecting everybody together. So we're now going to bring on our next guest, who I think a graph celebrity.
For sure.
Absolutely. So next on, we have got Luan Mesquita, who is the VP of Engineering at GraphQL. So let's bring Luan on. Hello. Good afternoon. How are you?
Hi. Good. Hi, Lou and Alex. Thank you very much for having me here. I'm super happy to be part of this.
Thank you so much for joining us.
Exactly.
My pleasure.
So, oh my goodness, we have we have so many things we can talk about. The kinds of graphic things you've been getting up to, the many years of involvement.
Yeah.
We're going to ask you the first question. I think everyone's going to be asked the same question. How did you discover graphs? How did you come across them? What was your, what got you excited about them and hooked?
Yeah. Okay. So I was working in server software. It's now I don't know who it's been acquired, but it's a people management company, and I worked in the platform team. So the product that we were building kind of dealt with people in a company and everything they do. So their learning, certifications, their next jobs, their career paths, succession planning, everything. And in the platform team, we had this challenge to build what was called a person profile. So very similar to your own profile on LinkedIn, but it kind of sucks in everything about a person, right? We were kind of composing that from tens of tables, I think 30 or something, and it ran into to build this profile took us easily, just under a minute. And, then we started to denormalize all the tables and try and make it faster. Then we put it into a stored procedure. So, what that story sounds like. And there had to be a better way, right? Because as we started to expand and, traditional, HCM software kind of moved out of this linear list of your accomplishments, and there was social media, and then you started doing, writing blog posts or speaking. There are only so many ways you can represent this information in tables, right? So then we started to do clever things like, have a table. So we kind of tried to take the schema out of the schema, essentially. So you would have like this giant table with, string 1 to string 10, and most of them would be null. And then you try to bring it all together, right? It was crazy. So there had to be a better way. And believe it or not, I was looking at other, at the time, very popular, the new category of NoSQL. And someone we were working with someone ex-Google, and they recommended I look at big tables. So I kind of okay, let me Google big table. That was my first NoSQL. And then I looked at it and I was like, okay. But then, the second result, and this is pure, I don't know, destiny. The second result was this thing called a graph database. And so I clicked on it, and it was amazing. And then it led me to Neo4j. And this was Neo4j more than 10 years ago. So 0.7, no cipher, no server, just the jar file, which you included in your AND script. And it had this root node, so it was amazing. No labels, right? It wasn't a labeled property graph at this time, but it was the best thing ever. It really, really was. Overnight, we built that profile, or I did. You just connected everything together. It made complete sense. Used a traversal API to get from one to the other, and that was it, right? And then that sort of, I've just never turned back from there, because it represents, your video today was amazing. I really, really loved it. And it's true, graphs are everywhere. I think my old laptops have that old Neo4j sticker. The graphs are everywhere in Cypher. And you see it everywhere. I see it in every domain. I see it in every project. I see it in everything you do. But that's how I got started. And I have no wish to stop doing it. It's really my happy place to work with graphs.
That's so cool. Maybe just quickly, comparing 4.2 with 0.6 is probably going to be very hard. But you have the whole lifetime, basically.
For those out there who are thinking about upgrading from 0.7 to 4.2,
exactly.
Yeah, it's really, really amazing. From the time it started to where it is now, I think it's grown like crazy. All the features are amazing. They're very much required. Cypher kind of turned everything around. When it came up, there were a couple of, sort of doubting Thomases when Andres proposed Cypher, and we were like, but you can just write a Java traversal. It was that, and then Cypher came out, and then there was no looking back from there. So the sort of innovation that Neo4j has actually brought to like the graph database space has been amazing, really, and it's a fun product to work with. The community, I think, makes it even better. I would say the community, I would go as far as saying the community is probably the biggest distinguishing factor between Neo4j and like other graph databases. It's just amazing.
It's cool. Really amazing to hear that. Yeah. I've just seen a comment in Discord saying, so Jennifer's heard you speak several times, but had no idea about your backstory of how you discovered Neo4j. And that's a cool backstory. We're going to struggle to top that, I think. The gauntlet has been put down. So
yeah, I have a snapshot of one of my old blogs, which doesn't exist anymore, but when I was trying Neo4j, and I was questioning some ridiculous nonsense about why an API threw some sort of exception. And at the time, it's more than 10 years ago, it was Emil that actually, responded to that comment. And I was like, this guy is so cool. And I was like, okay, I'm going to like keep that piece of trivia. But it was this, right? It was the people at Neo4j that were willing to listen. It was people like Michael Hunger that I just, have to call out. That was, part of my journey all this time, and giving me advice professionally, personally, having that belief. I think this community is amazing. I have a lot of friends there, so it's really, really cool.
It's really amazing.
Super good. Yeah. What are you currently working on? What's your current exciting project?
Yeah, so we so at GraphQL, this is our first product, Hume, and I think it's in the right place at the right time, because a couple of years ago we were all about spreading graphs and trying to get graphs to be sort of acceptable as a mainstream database. Many years ago, it was really, really, really hard, right? So I would say like a couple of years ago, it was a huge success if you managed to have a graph, right? Now I would say a vast majority of companies have graphs. So that problem is sort of almost, I would say, or close to being solved. And now the next thing is, what do you do with that graph? So you have your data in a graph. Everyone knows how to get data in a graph. Everyone understands why the data should be connected and why it makes sense to be in a graph. But now we need to take it, one level further, and that's what we're doing with Hume. You have the graph, you have the data, but what are the insights you can get out of it, right? How does the graph actually aid your analysis and your thinking, and kind of brings that extra intelligence to you as a human working in whatever domain you're working in. So that is super interesting for us, and we really enjoy building this product. We see so many use cases. We have very happy customers, and that's our next. That's what we are passionate about at the moment.
That sounds amazing, and yeah, we've seen Hume. It's very exciting stuff. I'm going to pick something up there that you said. So I'm curious now. So you talked about getting this graph acceptance. So how have you seen that over the years? So obviously from the dizzying heights of 0.7 back but yeah, certainly, how are you seeing that? How are you seeing the graph message? How are you seeing it being accepted now compared to over time?
Well, yeah. So right from the early days of Neo4j, ever since Neo4j had an Intro to Neo4j course, which is a very, very, very long time ago. And I've been a trainer for Neo4j. I was the only trainer, I think, in Asia for years, right? So I ran all these Neo4j courses. I would kind of like, fly over to a place, and then we had a class of 30. And I did this like over and over and over again. I think I probably trained like 400 or 500 people in these classes. And at every one of them, it kind of got easier as the years passed, because it was always a cool thing, right? Graph technology was a very cool thing. But then we always had this barrier of the developers and the engineers thought it was a cool thing because obviously you could do your job so much better. But then we couldn't quite break through that barrier of having it accepted by, the decision makers. And at that stage, it was like, when very earlier stages, it was just, nope, too niche, haven't heard about it. What is this jar file? Long ago, right? Then it sort of went to, okay, but can you fill up this table, like 3-page table, where you have all the features of a relational database like Oracle, every obscure feature ever, and you've got to tick whether Neo4j or a graph database has it or not. And of course you couldn't, right? Because it didn't make sense. And so that became the next stumbling block. But now you can kind of go into any reasonably sized company. I think the smaller ones are easier, but even at the enterprise level, government agencies, you can kind of go there, talk about graphs, and nobody will look at you as though you've kind of walked in from another planet. They know it, they know the advantages, and they want it. So I think this has been the big shift. So you don't have to convince people anymore why you need a graph. They want it. You just have to get it to them, and then help them sort of shift that thinking from how do I think in disconnected data to connected data. And I think there's that point, when that flip that switch kind of flips in your head, you can never go back. And once you've broken through that point, then it's perfect. So yeah, it's far easier today than it was 5, 6, 7 years ago, for sure.
That is really, really cool. So what gets you really excited? So what are you really looking forward to in the near future? Sort of, can't wait for this to happen. What's...
Yeah, so it's really about this, right? How do you take the data already connected in a graph and do cool stuff with it? So how do you predict things? How do you discover? I mean, we always talk about uncovering hidden connections, right? But I still think it's at a very early stage. It's very low level, if we were to kind of use that analogy. But how do you exploit that power from the graph? What I would be excited about is to see graphs become even more mainstream as part of applications. So Shilpa was on earlier and she spoke about jobs, which is very, very close to my origins in the graph space and the whole managing of people. And it's kind of amazing that I just cannot believe that more companies aren't doing this already in the people space. So I'm looking forward to talent being sort of uncovered. Talent being uncovered with, graph connections, people getting more opportunities in this sort of space, discovering more stuff. So really insights, applying that intelligence from the graph into like a meaningful application without necessarily having analysts write queries. I think that's where it's going next. And yeah, and we're going to be part of that journey. So I'm super excited about that.
Absolutely. And I've got all the questions. I don't know if Alex has. I am going left field here. So, being a speaker of many conferences, if you were to give a prospective speaker some tips, so 1 or 2 key tips for preparing for a presentation, what would you recommend? What would be your...
I'm not sure you're asking the right person because I'm kind of I'm always struggling at the last minute to put my stuff together. But I would say, it kind of to me it makes sense to speak about something that you really love, and I think that takes away most of the pain, because you love it, you're interested in preparing for it and speaking about it, right? So I think that's like the first hurdle, rather than picking up, some random trend that you would like to speak about. So yeah, loving what you want to present. I think the other tip I would have is to know your audience, because, for example, the audience at the Nodes conferences is significantly different from the audience at Graph Connect, for example. So you might have really the same talk, but it's going to be really tailored to what that audience is looking for. I think that there are sometimes we sort of make the mistake where we get very technical for maybe business audiences, and then you don't actually connect and share that message that you wanted to convey. So I think that's important. And the most practical tip is, have your slides ready at least a week in advance so you can practice it and not the night before. That's very, very stressful. But yeah, a lot of diagrams, a lot of, I find like showing the schema often helps people, visualize what you're trying to convey through the diagrams. Yeah, and that's it pretty much. Yeah.
Very, very useful tips, and absolutely
especially
true.
The slide one. Yeah, that's.
Yeah, I would like to do it myself, but since you asked for advice, I'm happy to give you advice I don't follow.
It's sometimes it's hard. It's I remember all these events we organized, physical events, obviously, and it was we have the speaker line up and everybody's coming, and I said, hey, you need to give me your slides before, and because it needs to be in the machine in the back of the room, because otherwise I cannot present what you're going to talk about. And then is 2 a.m. in the morning before the day, is that fine? Is that enough time for you to?
It's really tough with the remote conferences. I mean, this is really a challenge because with the in-person ones, you could just kind of walk up with your laptop and edit the slides as you're walking to the stage, and no one would know any better. But with recorded, it's tough.
Yeah.
Really tough.
Can you just pause the recording for a second? I just need to change a typo in my slide.
Yeah, the typos, that too. Yeah.
That's brilliant. No, but it's so absolutely super, super useful. And like you say, it's when you talk about something you love, it just flows. It absolutely flows. No, thank you so much for that. That was absolutely amazing. Loved the backstory. Absolutely brilliant. I love. I think we need to set up a user group, which is the 0.7 user group where
veterans.
People, exactly, the veterans. So they talk about the good days.
Yeah. Just give it a cool name, please. Don't call it like Neo4j old age home or something like that. Like
it could be. We can insert like an extra zero sort of before you get to the docs. So it could be the double, like the 00.7 club. Play on James Bond or something. Special agents.
Yeah, as long as it's cool, it's good. I'm happy to join.
Excellent. Thank you so much for joining us.
Thank you very much, Luan. It was great.
It was really, really fun to be here. Thanks very much.
Before you go, quickly, where can people find you if they want to reach out?
Well, I'm on LinkedIn. I'm on Twitter at LuanM. The Neo4j Slack, the Discord, the community, pretty much everywhere the Neo4j community is. So, feel free to reach out. I'm always happy to talk graphs.
Cool. Thank you very much, Luan. Have a good rest of your day.
Thank you.
Yes, thank you.
Bye.
Have a fantastic celebration. Take care. Bye-bye.
Thank you. Bye.
Wow, that was really cool.
Wow. Yeah. I like your idea. Special Agents 0.07.
Special Agents group. Yes.
Yeah. Yes.
That's so going to be a questionnaire. Right. So we are now going to welcome our next guest. That's Mike Morley, who is the president and co-founder of Monome Technologies, Inc. So let's bring Mike on.
Greetings.
Hello. Good morning.
Welcome.
Good morning. Yes.
Go on. We're going to ask you, what time of the morning is it that we've brought you?
That's not too bad. It's 7:30 here a.m. Early for the programmer, but I couldn't resist. I saw the Apple II in the intro there, so I thought I'd put the Graphs Everywhere up on it.
That's cool. Yeah.
The attention to detail. I can just see it now in the background. Yeah. I love that you've turned this on and you've put in the go-to. Like, oh man.
Yeah, there you go.
Top marks. Right. We've been doing this with everybody, so there is no escape. Tell us, how did you find out about graphs? What was your graphy eureka moment? What grabbed you in?
I can't claim that like Luann with not 7, but that was pretty amazing. But yeah, I actually I was working at an environmental company, and so I'm a geological engineer by my background's in geological engineering, which is environmental and water and that sort of thing. And one of the holy grails for that entire domain is trying to create a unified model of the environment, surface, subsurface, structures, facilities, all this sort of thing. And the company that I was working at the time, we were in the process of trying to unify a whole bunch of environmental data and bring it all together to do environmental impact assessment analysis, which is studying and understanding and contextualizing the environment and trying to minimize impacts of various projects as you go in to do this. And also doing other sorts of analysis like groundwater modeling, flow analysis, this sort of thing. In that domain, I mean, the big challenge there is relational models don't actually do a very good job of enabling you to represent the physical reality that's out there. So I'd used a number of different patterns for doing this, and I think as Luann had mentioned, it was things like NoSQL databases, Kimball, star schema patterns, OLAP, all those things. And invariably you'd run into this wall where the model just wasn't, the thing would grind to a halt, or it would slow down, or you couldn't bring in all the data in the way that you wanted, or it would. The one that was really frustrating was you'd end up being boxed into a corner. And if you had a different question or a different line of inquiry you wanted to go down, unless you'd factored that in right at the start, which you never do, you had to do a lot of work then to bring in this other aspect. And then I found Neo4j, I think it was either 2009 or 2010, same sort of exploration. I'm looking, how do you solve this? And I came across this blog post, and it actually might have been a GraphAware post actually, on this graph database thing, and I started looking into it, and I was like, wow, this is amazing. And then it just sort of went from there. And the capabilities, I think that was also something, when Cypher really started to take off and whatnot, and you start looking into that piece. And then especially when the spatial extensions were at it, that's where it really started to, the potential really started to come to life.
That sounds really cool. I'm going to have to dig in a little bit because I do have a little bit of a background in environmental impact assessments from an ecology perspective. So I would love to know what kind of data have you been putting in? How have you been using a graph to pull this together? What advantages from just collating the data and that kind of thing? What real benefits were you getting from being able to pull this together in this structure?
It's really interesting because it's the fact that the environmental data in particular, whether you're talking about trying to model something that's a mining operation and how that interacts with the environment around it, or whether you're talking about energy operations, this kind of thing, or whether you're doing a remediation reclamation type of a study, what you always end up running into is the fact that the data that's associated with the different facets that you're trying to model, the surface data, the subsurface data. And the other thing that's really interesting about the geoscience environment is the fact that so much of this stuff is text-based, textual, unstructured data. So you have this, highly structured data around the way you're setting up the different aspects of the numerical types of analysis that are typically done. Then you have all this unstructured stuff. Like if you look at, in particular, we've been doing a lot of, we've actually been doing a number of presentations, a series on this for the last few years, spatial experiments using Neo4j. It's up on our GitHub. And the really interesting there is that a lot of the data that's associated with the environment tends to get trapped in these environmental impact assessment reports. So we were doing this one project down in the States where the historical data was all in reports that ran from the sort of the turn of the century all the way up to fairly recently. And companies, they love doing this. So they write these big giant reports, they stick all this really useful information and they trap it in text files. So the first exercise was basically trying to extract all that stuff out. and then put it into the knowledge graph. And this is where Neo4j is brilliant, because you can do all of the decomposition and construct the graph around that. Then you can bring in all of the other aspects, like the actual numerical data that's associated with the environmental assessments, whether you're talking about samples and all the data associated with the samples. Time series data works very well. You can connect all that in. And then when Neo4j added in spatial extensions, that opened up a whole new field where you can actually model physical structures using graph. And when you look at the way the environment, most of the environmental models, whether you're talking about boreholes, whether you're talking about groundwater numerical models, mine models, they're all actually linked list or mesh structures. So using the Neo4j spatial extensions, you can assign spatial or Cartesian coordinates to nodes. And you can use those structures to actually represent physical things like boreholes, which are linked lists, or like environmental flow nets, so meshes of flow gradients and things like that. If you're talking about buildings, you can actually take building models, and Will Reynolds, I think, has done some really great work in that domain, projecting Revit models into graph structures. And then you can do all sorts of analyses and unify those analyses with other sorts of surface and subsurface analyses.
No, sounds really cool. I'm going to cheekily ask, could you explain a bit more about a mesh? What does that sort of look like? What does it entail?
Yeah, so it's actually, I'm hoping to do a further experiment with this, coming up with, assuming our paper gets accepted for the Nodes conference. When you're looking at modeling something in sort of whether it's like a physical thing, let's say it's a subsurface model of layers of sediment, for example, soils, right? So what you end up doing is you'll put boreholes down through this, and you'll log the boreholes using, this is a layer of till, this is a layer of sand, this is a layer of sediment, silt, and then clay. Let's go with that. So a geologist will basically describe those things. Then what you'll do is you'll pop a whole bunch of boreholes in the ground, and then you'll construct basically a series of you'll construct basically a network of those things. And then what you do is you start linking them all together. So you'll link this element of this borehole. So you got sand over here, you got sand over here, you got sand down there, and then there might be a fault or something. Then you'll have, these different types of sediment. So you'll construct these layers of networked meshes. And the way that works is you're basically just connecting nodes together. So this is typically done in two different ways in traditional geoscience software, where you'll have the model separate from the data. And what Neo4j, I think, opens up the opportunity that exists there is you can actually bring the data and the model and unify them into the same thing. So you can actually create mesh structures in the graph database itself without having to have a separate external storage for that. And once you do that, then you can link everything else into that, all the knowledge.
Absolutely. And I think you've touched on a really powerful thing there, is this idea that you can maintain multi-dimensional data structures within a graph.
Exactly.
And you see that as a common theme across a lot of things. So if you're looking at IT, let's talk about network management, the fact that you have a multi-dimensional structure with regards to applications you're running, physical components, particular roles, all that kind of thing. And you keep seeing that same principle being able to apply, and it's really exciting to see how that's being applied in a sort of environmental perspective about how you can start to link the different bits together. So there's one thing that that was quite exciting and interesting for me, is that you're talking about the fact that obviously you think about these typical environmental reports where something will go off, and it tends to be like a textbook, isn't it? I mean, these things are huge.
Huge.
So what kind of processes have you been doing? What kind of journey did you go through to be able to turn these monitor stands into something that's digestible and searchable and accessible?
That's really interesting. So that problem kept cropping up when I was at the environmental company. So, and then as the capabilities of Neo4j continued to improve, so I left that organization in 2016, started Menome. And the objective there was to actually construct a system, which was a multi-agent, essentially a multi-agent pattern. We've done some developer community videos on that you can look up. But essentially, it's a whole bunch of little agents that cooperate together to take documents and decompose them down and then construct graph structures out of them. Menome was actually acquired by RCurve back in November. So we are continuing the work, and now we're able to bring in more people and more data scientists to help us really augment this stuff out. But some of the stuff that's been really interesting in that domain are the fact that you can use these little, they're basically just little Docker containers that are all hooked up with a messaging using RabbitMQ or Kafka. And each agent does sort of one function inside of this chain to take a document. There's one that kind of does a pre-scan OCR thing. There's another one that then starts to look for patterns inside of that and start to break that stuff down into graph structures. One of the things we've done recently with a company is, and it gets into this whole domain of regulatory, how the regulations impact the way you go about doing these sorts of assessments. And this stuff's all stuck in text documents. So we've actually now got an algorithm that will go through and is capable of identifying and extracting regulations from these sort of regulatory documents, and then we're turning them into what we call graph documents. And then you can use the power of the Graph Data Science Library to start to do similarity analysis, saying, okay, we're doing this project in this region. This is the type of project that it is. It relates to maybe it's a remediation project or something, and there's certain standards that are associated with that. Here are the regulations that will apply to that domain, and make recommendations about that.
Yes, that's really exciting, and I guess as well, you then have this scope of, because presumably in different regions, different rules are going to apply. So you can then start to do like a delta between, well, okay, in this, in region A, this is fine. In region B, this is not fine. Actually, in region C, it was fine, but we can now look at how that regulation changes over time. So we can do an assessment. Oh my goodness,
that's exactly right. And you can also then, and the other thing that's really amazing about the graph database is it's not just like in the past, it's like, oh, you stick all your stuff in a SQL thing and it just sits there. In the graph, because it's actually an analytical platform, you can then do, the all sorts of different types of analyses in that environment. So you can actually bring in, various algorithms and whatnot to actually run the analytics that you need to do right in situ.
No, that is so cool. So
that's very cool. I mean, I was just wondering if you mentioned you're using database. You also mentioned you used the graph algorithm, so you kind of like use the almost all of the bandwidth. To you, is visualization also something that is important for you?
Absolutely. I'm glad you actually asked that, because we have done some interesting experiments with the GraphXR folks who made that really, that's Kinviz. And we can actually take, these sort of spatial structures from the graph and put them and you can visualize them in 3D in that environment and actually look at them and whatnot. And recently we did a presentation at YYC DataCon where we took some MIME models from a company called Myra Geosciences. They're based in Montreal, Canada. They make a really interesting bit of software called Geospatial Analyst. And we can actually take models from that and project them into Neo4j and back. So then you can use that environment to do these complex geological visualizations. And we're working on seeing if we can actually directly connect those two things together. We also have open sourced, we took the Kepler GL system, which is Uber's open source kind of thing. And there's some really amazing stuff you can do with that using the H3 polygons for doing geospatial clustering. Then you can use that to augment Neo4j by turning that into a plugin. Then you can actually do geospatial analytics by bringing different data aspects together. And then one of our students actually did a really nice bit of work where he connected Kepler up to Neo4j. So we've open sourced that, and I'm currently just working on trying to turn that into a graph app to go into Neo4j desktop.
Very cool.
Yeah, that is, yeah. I'd like to see that.
It's fun. Yeah, we're going to publish a bunch of the stuff that came out of that, actually, where we'll have a number of examples and so on of the things that we were doing at that other event.
That is really amazing. So I guess I'm gonna. I've been asking the same question to everybody, so I'm going to continue. So the next coming few months, what are you really excited about? What are you sort of like just looking forward to and want to see happen?
Oh boy, there's so many things. Like it's just, that's actually the hard thing is, okay, I've got to kind of box this stuff in. It's like, okay, what's the next thing I need to do to kind of prove this out, move it forward? So yeah, we did submit a paper to Nodes, and I think that's where we're going to try and move the ball forward a bit more on this whole, modeling physical systems with graph. The thing I would really love to pull off there is to take an actual, subsurface model and run basically the same kind of numerical compute stuff on it. So the one I'm kind of thinking of seeing if I can try would be ModFlow. So taking some ModFlow data. So ModFlow is the thing that lets you compute, transmission of groundwater flow and contaminants, this kind of thing. And it's an old really old. It's an old Fortran thing. So one of the things I want to see if I can do is take the graph structure, punch it through that thing, and then put it back into the graph, and then start to use some of these visualization methodologies to project that into, to actually see where the information, where the contaminants flow and this kind of thing. And then start to work and unify that with some of the surface information and so on. So we're going to keep kind of plugging away at that over the next bit. And then the other one I'm really excited about is this idea of graph documents, the regulatory piece. So we're continuing to drive that forward as well.
Wow, that is cool.
So many exciting things here. I just, because you almost get a situation where you can start to potentially look at cause and effect as well, and you're starting to bring things in together, and well, this event happened and this event happened. Is there a chain that effectively is going to happen this, so we can predict that these what looked like separate events actually weren't so separate. So wow,
that's totally like that's another brilliant. That's a really great observation, because you're absolutely right. We did a number of years ago with a project that we were trying to characterize mine subsidence to mitigate the effects of abandoned mines with respect to housing development. And that used a bunch of Monte Carlo simulation things. And again, it was fairly complicated to do at the time because the technology was limited. But you're totally right. In the graph space, again, because you can model event sequences as, a chain of nodes with potential outcomes, you can do a bow tie analysis, which is where you have a potential impact sitting in the center of these sequence of events. You can then model the events that might lead to that event, that negative event or whatever you're trying to prevent, the risk, and then model the potential outcomes of that, and then use that pattern to potentially mitigate those things. The other one that's really interesting is site characterization. We also believe that you can use graphs would be a very powerful tool for using the clustering methodologies to actually understand and characterize environmental sites based on past historical impacts, and then use that to make predictions about and minimize impacts of future activities.
So cool.
It's fun, man.
Not
enough time is the problem.
I'm sure we're going to have to organize another session or something. We'll chat.
Yeah, we should. Wow, yeah. Thanks, Mike, for taking the time today, for joining us in this session. It was really great and really, really cool projects you're working on. If people want to find you, want to reach out, where can they do so?
Oh, they can certainly get me on LinkedIn, and then on rcurve.com. We have a blog that we're now starting to set up there. So a bunch of the stuff that we're doing with respect to these experiments and whatnot, we're going to be publishing there. I've actually got one that should be coming out in a few weeks here. So yeah, those would be the two main ones. And then absolutely of course, on the Neo4j community site, and I'm on the Slack as well.
Fantastic.
Perfect. Super.
Thank you so much. Thank you for joining us.
Yeah, thanks for inviting me.
Thank you, and have an amazing rest of the celebration day.
Thanks, I got my shirt on.
Day. Thank you for joining.
Thank you.
Nice t-shirt.
Exactly. Yeah, perfect.
Thank you, Mike.
Right. Thank you. Oh, that was amazing. That's really amazing community stories. That was really amazing to hear about what Shilpa's doing, the projects around recruitment, and sort of being able to link people together with trials. Hearing about how Luann discovered graphs, the Special Agents Club. We've got to make that happen.
Yes, I think
Special Agents Club. Oh, yes.
Yeah.
And as well, hearing about Mike and what projects he's been doing, and specifically around that space, and being able to link all of these environmental factors together, and how do you make that smart with the various regulations and the documents. Oh, really, really exciting to hear about these community stories. So what we're going to do is we are going to move into our next section, but I think we shall do a quick reminder because I love that video, so I'm giving it mileage. I'm giving it mileage.
We
and
should,
again,
we should, yeah.
If you've got if we don't have your language and you would like to record the Graphs Are Everywhere, please do let us know. We would love that. So we're going to do that, and then we are going to have a chat with our colleague Will Lyon all about GraphQL. So watch this space.
Grafer finns överallt.
Graphs are everywhere.
Graphen sind überall.
Alright, graphs are everywhere, aren't they?
Los grafos están en todas partes.
图无处不在。
Grafy są wszędzie.
Grafikler her yerde.
Graphs हर जगह हैं.
גרפים הם בכל מקום.
Grafi su všade.
I grafy no padu.
I grafi sono ovunque.
Grafikler her yerde.
Grafen sind überall. Grafet är en givande. Graphs har jagä här.
Graphs berada di mana-mana.
Grafen zijn overal.
Grafen sind überall.
Graphs are everywhere.
Grafike je всюди. Grafలు ప్రతి చోట ఉన్నాయి.
Grafer finns överallt.
Grafen sind überall.
I grafi in padu.
Grafoች бăietă-mălă.
Grafoak leku guztietan daude.
Graful решения повсюду.
Jite kite graphs ein.
Grafer overalt.
Tu, wozu, gut sei.
Hey, Graphen sind allgegenwärtig.
Graphs ಎಲ್ಲ இடத்துலயும் இருக்கு.
Grafi jsou všude.
I grafici sono dappertutto.
Les graphes sont partout.
Графите са навсякъде.
圖無處不在。
Os grafos estão em todo lado.
Les graphes sont partout.
És grafikonak mindenhol vannak.
Le grafische tutta basso.
Graphen sind überall.
Los grafos están
En todas partes.
Graphs har jagah hai.
Grafos hay en todas partes.
Graphs are everywhere. Really? Are graphs everywhere? Yes, indeed. Graphs really are everywhere, and Cypher is used to query them.
Hello everybody. Welcome back. We are now into the next section where we are going to be talking about GraphQL. So before we dive into the GraphQL Community Meeting, I've got my colleague on, William Lyon, and it'd be really great if you could give us a quick intro to GraphQL, what it is, what's the Neo4j involvement with it, before we kick off the meeting.
Sure, yeah. So like you said, my name's Will. I work on the Neo4j developer relations team. And my goal is to help developers be successful building applications with Neo4j, and oftentimes that involves lots of other technologies. And GraphQL is one of those that we want Neo4j developers to be successful with. So GraphQL was used internally at Facebook starting, I think, in 2012, and then was open sourced in, I think, late 2015 or 2016. And it was something really interesting for the Neo4j community and the graph database community in general, because GraphQL makes this observation that your application data is a graph, and builds an API that allows the client to interact with this data as a graph in the context of relationships. And so really early on, we started looking at how can we better integrate Neo4j with GraphQL. Fundamentally, this means building API layers using GraphQL backed by Neo4j as the data store, which is what we're going to talk about in the session.
Excellent, fantastic. Thank you very much for that. So without further ado, we are going to be handing over to the GraphQL group. So I think first of all, Will, you're going to be covering some stuff to begin with, and then the meeting will start after that. Brilliant. So just going to quickly do this, and over to you.
Great. So it looks like everyone can see my screen there. So yeah, this is sort of a continuation of a series of Neo4j GraphQL community update calls that we've had throughout the year. And we thought that doing this at Global Graph Celebration Day would be a good opportunity to share this with the community. So you'll hear just a little bit from me talking a bit about using GraphQL with Neo4j. And then we also have some of the team from Neo4j engineering that have been working on the Neo4j GraphQL integration that'll go into a lot more detail. And then we'll be sure to answer any questions that come up. And then at the end, we have a really exciting announcement that I'm really excited to talk about. So hopefully that will be worth waiting for until the end. So let me just jump into this and talk a little bit about maybe first GraphQL at a high level. So we mentioned just briefly what GraphQL was a few minutes ago. Let's talk about it in maybe a bit more technical detail. So fundamentally, GraphQL is an API query language and a runtime and tooling for building APIs. So what that means is we're building this API layer that sits between the client. So the client can be like a web application, a mobile application, another service, and some data layer like a database, or maybe even wrapping another API, combining either one or multiple data sources and serving a unified GraphQL schema. So with GraphQL, we have a strict type system. So we describe the data that is available. This becomes the schema, the specification for the API. And then the client of the GraphQL API can inspect this schema so we can see what types are available, what fields are available on the type, and more importantly, how those types, how those objects are connected. So that's where the graph part of GraphQL comes in, is we are explaining how those types and how that data is connected. And then because we have this strict schema and type system, the client can then request a sort of traversal through this data graph, and the response matches exactly what the client has requested. So maybe let's look at an example here. So let's jump over to, this is a example demo GraphQL API that is out there that anyone can query using a movies recommendation data set. And here, this is a tool, by the way, called GraphQL Playground. This is kind of like a query workbench for writing GraphQL queries and viewing the results. And so let's zoom in a bit. And so on the left, we have a GraphQL query. So you can see here, this is starting to look for movies. And then this where argument is looking for movies where the title contains the matrix. And then this piece here in the GraphQL query, this is called the selection set. And this is where we're specifying the fields, the traversals through the data graph that we are, in this particular request, interested in coming back. And over on the right, we can see that the response data exactly matches the shape of what we've requested on the client. And I can add other fields here. So you see I have this tab completion, which is a really nice feature of GraphQL. And because we can introspect the GraphQL schema to see what data is available, we can build really nice tooling like this tab completion. We can go on and say, for the actors in the matrix, what are other movies that they've acted in? And this data then comes back now in the request. So we can look at some sort of interactive tooling that allows us to explore what entry points. So in GraphQL, the entry points are query fields or mutation fields for updates. Cool, so that's a high level look at querying GraphQL. How do we build GraphQL services? How do we build GraphQL APIs? Well, there's basically 3 steps that we typically go through. First, we start with defining those GraphQL type definitions. So we said that GraphQL APIs have a type system. We define the types, the fields, how the data is connected. This becomes the specification, the schema for the API. And then the next step typically is to implement what are called resolver functions. And resolver functions, this is where the data fetching logic lives. So for each type, for each field in our schema, we have a function that has the logic for going out to the data layer, if that's a database, if that's another API, wherever that data layer is, fetching that data and bringing it back. If it's a mutation operation, how do we update? How do we store? How do we save data? That lives in the resolver function as well. So we can see on the example here at the top, that's an example type definition for this is a API for searching for sessions at an event. So something like an online conference, we have sessions that have a title description, some presenter, so speakers, there's some theme to the session. And then the query type, this is the entry point for the API that takes a search string argument. So I want to search for sessions by title or description. So that's our schema for this example API. And then down in the bottom right is our resolver functions. And we can see here that we have a resolver for each one of these fields. And we're using sort of an ORM-like API here to go out and query a database. So we start first by querying for sessions by some search string. And then when that comes back, then we have to go look up the room, the theme, and we also have this recommended field that's going to be maybe computationally expensive to go figure out what are similar sessions. So these resolvers are called in a nested fashion. So we start with the top level root resolver, and then we call resolvers for nested fields in our selection set. Combining these then, combining the resolvers and the schema into what's called an executable GraphQL schema, and then serving that over the network. That's kind of the third part here where we're serving our GraphQL API. And those are basically the 3 steps to building a GraphQL API that we typically go through. I call this sort of the standard approach. But there are some common problems and challenges that come up with this sort of 1, 2, 3 step approach. One of those is this idea of schema duplication. So I'm maintaining a schema for the API and also for the database. So that's a bit more overhead to work with. Because we said that GraphQL models our data to the application as a graph, if we're then on the back end storing that not as a graph, but in maybe a relational database or a document database, then I have this sort of mapping and translation layer that I have to work with in my resolver layer. And there can also be a lot of boilerplate code. So in the example that we had, we were using that kind of ORM type API to go and query our database, but there can be a lot of boilerplate to set that up oftentimes, or if we're writing a lot of data fetching code, it's things like setting up a connection to the database, executing that, writing the database query code, massaging the results as they come back to get in the format that we expect. And then we mentioned when we were looking at our resolver functions that resolvers are called in this nested fashion. So in our session example, we're starting off searching for sessions by a search string, by looking at the title description somehow. Then when those come back, we then have to go back to the database to say, okay, what is the room, who's the speaker for this session, and so on. And if we do that for lots of results, maybe our session search here maybe returns lots of sessions that we then have to go back to the database to request the details for. That can result in lots of round trips to the back end, which can slow down performance. So this is this idea of the N+1 query problem. And there's some solutions to this, such as kind of bashing and caching, but this is kind of a common problem that comes up when we start to build out our GraphQL APIs. So I mentioned earlier that when GraphQL was first open source, this was something that we were very interested in building Neo4j GraphQL integrations to make it easier to build GraphQL APIs backed by Neo4j. So in talking to users early on and looking at kind of what folks wanted to accomplish, we realized some of these pain points, such as having a lot of boilerplate code, this idea of having to maintain two schemas can really impact developer productivity, performance issues around N+1 query problem. But I think fundamentally what we realized is that because GraphQL models your application data as a graph and presents it to the client as a graph, there's a huge opportunity to leverage the benefits of a graph database on the back end, both for sort of the intuitive nature of working with that, but also if we think of a graph database like Neo4j, they're optimized for these kind of nested traversals through a data graph that we're often expressing in GraphQL. So it made a lot of sense to dig into building some Neo4j GraphQL integrations. And the feature set for those are kind of what I want to talk about next. So starting off with this idea of GraphQL first development. So this is an idea that you start with your GraphQL type definitions, and that then drives the rest of your API and application. And that concept comes to our Neo4j GraphQL integrations by mapping the types defined in your GraphQL schema to node labels in the database, fields to properties, and then relationships are modeled by these references that you see. So in this example, we're looking at movies. Movie has a genres field that is an object array of genres. So that's representing a relationship in the graph. So we can define the Neo4j property graph model using GraphQL type definitions. We don't then have to maintain two schemas. We then use those type definitions as the starting point for then generating a CRUD API in GraphQL. So we saw earlier this idea of the entry point in your GraphQL API as queries, mutations. So those are then generated to give you entry points for each node label, each type that you've defined, adding things like ordering, pagination, filtering, and things like this. Then for any arbitrary GraphQL request that comes in, we're able to translate that to Cypher and handle the database call. So this is really important for a couple of aspects. One is reducing a lot of boilerplate, so we don't have to deal with writing the data fetching logic in those GraphQL resolver functions if we're using the Neo4j GraphQL integrations that we saw at the beginning. This is all handled for us by the integration, and this also addresses this N+1 query problem. Because we're sort of going through the entire GraphQL query and generating a single Cypher query, that means one round trip to the database. So going back to our session and speaker example, we don't then have to think about, okay, go to the database, find the results for the sessions, come back, and then request details for each session. Instead, the database query is generated for the entire GraphQL request and just one round trip to the database. And again, because graph databases are optimized for these traversals through the data graph, that then gets optimized by Neo4j. So we talked about how we can have CRUD functionality basically for free just by defining our GraphQL type definitions. What if we want to add custom logic? Well, we can do that by using what's called a GraphQL schema directive. In this case, the Cypher GraphQL schema directive. So this allows us to sort of annotate our type definitions. Schema directives in GraphQL are sort of like GraphQL's built-in extension mechanism. So it's some indication that there should be some custom logic on the back end. And what we do here is we then take that Cypher query that's attached to a field in the GraphQL schema, and when that field is requested by the client, we execute this Cypher statement. So this allows us to define custom logic in our GraphQL API, taking advantage of all of the power of Cypher, and still take advantage of that, generating a single database query from a GraphQL request. So this is a really powerful feature that I'm really excited about. So if you've been following Neo4j and looking at the GraphQL integrations, you've noticed that there have been a few implementations of this idea of the Neo4j GraphQL integration. There's a JavaScript library for building Node.js GraphQL APIs. There's an implementation in Java for using Java tooling. And early on, this is actually our first project, was a Neo4j GraphQL database plugin where we were actually serving the GraphQL API directly from the database. So, and then there's also tooling around this idea of Grand Stack. So if you've seen Grand Stack talked about, this is this idea of GraphQL, React, Apollo, and Neo4j database. So sort of tooling around the core Neo4j GraphQL integration to make it easier to build full stack applications. So there's started a project around that, a command line tool, and then a graph app in Neo4j Desktop. So we have seen some of these tooling and library that have been out there previously. These were built under this Neo4j Labs label. So, well, not official products from Neo4j. These are things built by the community. Some folks internally at Neo4j worked on these as well, but really not offered as something that is ongoing maintenance and support. However, what we have been talking about in our GraphQL community update meetings so far is the official Neo4j GraphQL library, which is now available as a beta release. So this is really exciting because this means that there's now a dedicated engineering team at Neo4j working on the Neo4j GraphQL library as a fully supported and open source project that delivers the features that we talked about in this idea of these Neo4j GraphQL integration. And so next, you're going to hear from some folks on the Neo4j GraphQL engineering team talking about how to actually use this library, what are some of the features available in it in a lot more technical detail. So I think with that, we can cut over to Dan, who's going to take us into a deeper dive example.
Can everybody hear me?
Hey, Dan. Yeah, I can hear you.
Hey, how's it going, Will?
Good, good.
Great. Let me get my screen on share. Okay, cool. Can everybody see? Great.
Yeah, I think we see it.
Cool. Okay, so I'm Dan, and I work as an engineer in the Neo4j GraphQL implementation. I'm joined by my colleague Daryl, and who you see just after my slides. And today I'm going to take you through a worked example of the Neo4j GraphQL library. It's essentially going to be a quick start, how to get up and running in a Node.js environment, and then just querying bits of that GraphQL API. So without ado, let's get on with it. So I really like Forrest Gump. It's an awesome film, and without a doubt, one of the best quotes from the film is "Life is like a box of chocolates. You never know what you're going to get." So with that in mind, let's give it some credit. Let's build an API and let's put Forrest Gump into our database. So to get started with Neo4j GraphQL, you're going to need about 35 lines of code. So here's our 35 lines just here. And what you're going to do first of all is require in some dependencies. So at the top here, I'm requiring in the Neo4j GraphQL class, the Neo4j driver, and Apollo server. And Apollo server is the tool that provides you the API and the playground, which Will just showed you previously. And then next up, what I'm going to do is I'm going to find some type definitions, and this is essentially our schema. The name schema and type definitions can kind of be chopped and changed, but we can actually dissect these type definitions. At the moment, they're just a string in the code, but let's bring them up a little bit bigger. So what we're defining here is a movie and a person, and each type corresponds to a node. And on each node, so for example, the movie, it has a property of title, and that's a string, and it's required. And then the person has a property name, and that's a string type, and that's also required. And then on the second line of the movie here, we have a relationship, and it's using, as Will mentioned, a directive, a schema directive annotation. And we're extending the schema and specifying that the actors of a movie is a relationship of type acted in. And the direction of that relationship is in. So with that all in mind, let's go back to the code. We have our type definitions in. Now we just need to fill in the rest of it. So we're going to construct a Neo4j driver. And here I'm using the Bolt protocol to connect to a local database. The database is running in Neo4j desktop. And then this is where the core of our work comes into play. We provide the type defs to the construction of Neo4j GraphQL. And then the return of that is an object, and one of the properties on the object is the executable schema. So here's the last few steps. What I'm doing is I'm constructing a Apollo server, providing it the schema that we have generated, and then doing some asynchronous processes just to spin that server up on port 4000 at localhost. So let's start that server. Node index, and it's telling us to navigate to localhost 4000. So I have this prepared earlier. Here we are in GraphQL Playground. This is what you'd be presented if you went directly to localhost 4000. And what I'm going to do is just navigate the schema section for a moment. So this schema is the result of an introspection, and it's showing us, for example, we have our movie type, and we also somewhere in here will have our person type. But in particular, there's two types that you would like to look at, and that is the mutation. So we have create movies, delete movies, and update movies, and then the same for people as well. And then if we look at the query type, which is down here, we have movies and people. And now these are essentially functions that we can call on the GraphQL API.
Sorry to disturb you, Dan. Could you make the font a bit bigger, please?
I can. Hang on. I think there's a way to do this in here.
I've interrupted your flow. I do apologise.
It's all good. How about, is that better? Any good?
Make it a bit bigger, maybe?
Let's go 25. Let's see what that's like. How about that?
Yeah, that's good.
Cool.
Thank you very much.
No worries. So these are essentially functions that we can call on the API, and they're automatically generated. So if we go back to the slides very quickly, and we provided these type definitions here. From just providing these type definitions, we generate this entire schema that's ready to be used in your application. So we set out to put Forrest Gump in our database. So let's do that now. So on the left-hand side, I'm going to start typing a query, and I'm going to type a mutation. And if I press Control Space, again, it gives me autocomplete of all the queries that I can perform on this API. And of course, it's going to be create movies. And then the input to this mutation is going to be an array of movie. And again, because we have this introspection going on and we've generated this schema for you, we can use IntelliSense in the IDE to fill out this query. So I'm going to say that the title of the movie is going to be Forrest Gump. Oh, a few R's there. And I'll just prettify that just to make things look a bit nicer. And then I'm also going to open a selection set and just ask for the movie that we created back. And this is fine. This will create a movie node in the database with the title of Forrest Gump. But a movie, of course, doesn't just stand on itself. It has actors and directors. So here I'll show you something called nested mutations, which Daryl after me will go into more detail. But I'll give you a quick preview. What we're going to do is we're going to create some actors at the same time. Expand this way, maybe we can't. And the actors are going to be created. So we're going to create the actors, and that'll be an array. Let me just prettify this so we can see what we're doing. And then inside this create array, I'm going to give a name, and it was Tom Hanks, the one that starred in it. Cool. Tom. Cool. And I'll prettify that. And now if I run that query, you'll see that we get the Forrest Gump node back. And then what I'll do is I'll open a new tab, and I'll just quickly ask for all of the movies in my database. So here I'm doing a query. I'm asking for all the movies. I'm asking for the title. And I'm also asking for the actors with their name. And if I query that, it's a blank database. You'll see that we get the movie, which is Forrest Gump, and the title, that is Tom Hanks. So with that, I hope that you can set up a GraphQL API with less than 35 lines of code. So it's definitely possible, especially if you get rid of the white space in this example. But that's it from me. So I'll pass over to Daryl next, who will jump into more detail about how you can use the GraphQL API. Thanks.
Cool. Thanks, Dan. Right, let me just rejig my windows. Put that one over there. Right, so I'm going to do a bit of a feature deep dive. There might be a bit of replication as I'm going to go into nested mutations, much like Dan did, but more going to explore kind of the choices that you have with nested mutations and to go through a couple of other features of the library. However, it won't be too deep as I'm pretty limited on time, so let's crack on. Great. So the first is nested mutations, and there's many ways to skin a potato. I'd rather not be skinning our feline friends, so I've changed that saying up a little bit. So what are nested mutations? Essentially, if you think about GraphQL, you are kind of, as you go down through your GraphQL queries, traversing through a graph as such. And nested mutations allow you to traverse through that graph, modifying as you go along, and you can chain together many different operations of different types. So you can do a create of something, then connect to a different node inside there, so on and so forth. So it means you can get pretty creative with how you change things up in your graph. If we take our favorite example data set, this one, you might actually recognize this example from the Neo4j Getting Started docs, but you have a movie, Forrest Gump, which has actors, and then it also has a director, both of which are of person types. If we then make some nice simple GraphQL type definitions for these, you'll see that you have a person, which has a name, born, which is an integer, and then a person can either act in movies or direct movies, and both of them are multiples in an array. And then as we move on to our movie, a movie has a title, it has a released, once again, as a year, it has actors, and then we're going to say like a movie can have one director and a movie must have a director. And this will become kind of apparent as to why this is quite important in the next slides. And we're using our relationship directives to tie all this together. As you can see, the direction here in these directives kind of hooks into the direction of the arrows coming out of our people and into the movie. So, as I said, every movie needs a director. So there's a couple of approaches we can take here, right? We can create a director first. So let's create Robert Zemeckis by himself. He's now sat there. And then if we then create our movies, we're going to create Forrest Gump with our release year. And then for the director field, we're going to connect to the existing person node, Robert Zemeckis. And that will create our movie and then connect to Robert Zemeckis. But then there's a different approach you could take, right? You could do update Robert Zemeckis and then create a movie as part of a nested mutation, creating Forrest Gump off of Robert Zemeckis. So it's kind of getting your head around these different approaches to getting your data all connected up. Additionally, you could actually just do this all in one go, right? You could create a movie and your director at the same time, saving those two mutations that you were doing before. And then now, as we introduce Tom Hanks in, if we already assume that we have our Forrest Gump movie and our director already in the data set, we can take a similar approach to what we did before, create our person, Tom Hanks, first. Then we can update Tom Hanks and connect him to our existing movie, Forrest Gump. As you can see, kind of sometimes we've got creates in there, sometimes we've got connects in there. It's really a nice flexible API for manipulating data. Alternatively, you could create Tom Hanks directly without, and then do the movie connection directly within that creation. A few different approaches to that. But then why would we do it as separate things? We could potentially just do it all together. But even when doing this, there's a couple of different ways for doing this, right? You can create your movie, and then you can nest down into your director and your actors, creating Tom Hanks and Robert Zemeckis all in one mutation. And as you can see, that's going to look something kind of similar to this diagram on the left, creating your movie first, and then creating your two people kind of a level deeper than that. But remembering this is all happening in one cipher statement anyway, so it's going to be pretty performant whichever approach you choose. But then you can think about your data slightly differently and go, well, actually, why don't we create our director first, then create our movie, and then create our actors of the movie? So lots of different ways to think about your data, but it means it's extremely flexible to the applications that you're building. If it makes sense for your mutations to look like in a certain kind of pattern, then this library can certainly accommodate for that. Great. So that's nested mutations. There will be a tiny bit more nested mutations over the next couple of sections. So now I want to talk a little bit about authorization and authentication, which is securing your data using a GraphQL directive. So this is a flexible GraphQL directive. It can be used on object types. So what we're doing here is we're extending an object type, and we're saying that in order for a person to create a post, they must be authenticated. Or it can be applied to object fields. So you could say, if you have a type of a user with a password field, you can apply an auth directive to that field, basically saying that you must be an admin to do anything with this password field, including view it. And then there's some additional fields you can apply it to. We support, as Will, I believe, went to, kind of custom cipher fields. You can also apply these auth directives to these custom cipher fields as well to restrict who can run those custom cipher statements. So at the authorization level, there's a few different things you can do. You can bind, which basically says when a user is creating or updating this ID field. So we've extended our type user, which has an ID field. Essentially, this is saying that ID field can only ever have the value of the user's JWT subject. So it means that, user 1 can't come in and change his identity to be user 2. That's always going to be user 1, and that's the only way you can do that. There are options for role-based access control. So what this does is, if within your JWT tokens you have a roles object, so the JWTs that you create for authorization are kind of self-managed. You assign the IDs that are inside them, so you can put a roles object in there This one here is like read invoice. And essentially you're saying that that role must be present inside the JWT in the context in order to read these invoices. But then you can kind of do more complicated things as well. So this is an allow operation. And what we're saying is that in order to update a post, you can go down these relationships. So a post has moderators which are of type user. So in this directive here, it will skip down that moderator's level to user and then query the ID of the users for the JWT subject. So it's not just for fields within the type that you're applying the auth directive to. You can also go to related fields as well. So that's a really quick overview of auth. It's extremely complex. However, there's some great documentation for it, so please check that out, as it's far too much to go into in like a very short presentation like this. So finally, the last feature I want to dive into is the OGM, which is a programmatic way to query your GraphQL API. So the OGM is an object graph mapper, which is a really, really similar concept to an object relational mapper, such as SQLize, which you might have used before, but these aren't a new concept for kind of relational or graph databases. They offer the same functionality as your GraphQL API and actually uses your GraphQL type definitions to create that OGM, which will be used. So slightly more complicated type definitions here, right? And I do want to go through a few different things here as well. So you have posts and you have users. Posts are related to users, as a user can have many posts, and a post can have one author. But then highlighting a few interesting things in these type definitions, there's some nice directives that our library offers, one of which is timestamp, which allows you to allocate fields to be timestamps based on operations which are either create or update, or you can have like an upsert operation, which will essentially be like a last modified kind of timestamp. I also wanted to highlight this auth directive here. This one's a bit different. It's using a where clause, and what that does will become apparent in this example. So going into the OGM, we can introduce a bit more into our type definitions. The first of which is this private directive. That's essentially saying this password field is only going to be available in the OGM. Really good for securing things, as the OGM is almost like could be internal to your GraphQL API, and then you can expose the rest of your user type over your GraphQL API. And then we're going to add in a custom mutation called signup. And the whole idea of this custom mutation here is that we're going to create our user objects in the database and then generate some kind of JWT and return that to the user who ran the mutation. So first we want to install the OGM package. This was actually previously built into the Neo4j GraphQL package, but we recently split this out into its own thing. We think that's a good direction to take for the library. So then what you need to do is get the OGM constructor from the Neo4j GraphQL OGM package. Then we can do new OGM, pass in our type defs, which we wrote down before, and then also a driver for the Neo4j database. I didn't want to put all of this boilerplate in here, but that would be how you create an OGM there. And then what you can do is once you have that OGM, is you can do ogm.model and then the name of some node labels which are in your database, which will also match your Neo4j GraphQL type definitions. And then what we need to do is define a custom resolver for the signup mutation. So what we can do is, using that OGM user model, we can do user.create input username and password. That might look really familiar, I hope, from what Dan did before, where he was creating those movies, having that input object, and then containing the fields which you want to go into that object. But then we can do something else, which is actually, before returning the object to the user, signing that JWT in some way, shape, or form. I didn't want to give an implementation here because it's going to be different for every single user who does it. And then returning that JWT as a string. That means what we can do is we can create our usual Neo4j GraphQL object, passing in our type definitions, the same ones that we passed into the OGM, and then that custom resolver, which we did for the sign up, and then we can host it over Apollo server like we would usually do. So then what you can do is do a mutation, sign up with an extremely secure password of password. And then what will be returned from that is a string instead of an object like you might expect from the library, which we usually do. So this is like just a JWT string. And then what you can do is pass that in the HTTP headers in future requests. This is all kind of documented in our documentation. So you can run a query, users, and then get the username, password, posts, content, and then you're passing in that JWT in the authorization header of the HTTP request. Now here comes a bit of magic. You saw that auth directive with the where argument before. Under the hood, this query is essentially going to become users where ID is this. And this is just a UID in this example, but that could be the ID that's stored within this JWT. So, and this will kind of happen on your queries and your mutations. So it can be quite powerful if you kind of want to restrict users to kind of accessing their own information only. So we're going to run that, and we're going to fetch all of those fields that we're asking for there. But we're going to get an error because, of course, we can't actually query the field password on type user because we marked that as private in our type definitions. So kind of proof that this works really well. We were able to access that password field while using the OGM, but we weren't able to access it whilst querying it over the GraphQL API. Finally, I just wanted to show that actually you can use nested mutations, which I showed before in the OGM as well. So, we're doing the same mutation as we did before here, which is creating our user with a username and password. But then we can actually extend that out. We can go posts, create, content. I just signed up, just an introductory post. Once again, kind of the same structure which we saw in the nested mutations before. So it's a nice familiar way of working, but it's equally as powerful as our main library. And that's that. So I believe Will has a special announcement to make.
Oh, we can't hear you, Will.
Sorry,
we got perfect.
Muted there. Sorry about that. Yeah, cool. Thanks. So we definitely want to answer any questions that folks watching have. So if you have questions, please drop them in the chat, and we'll bring everyone out to dive into those questions in a minute. But before we do that, I want to get to our special announcement that I'm really excited for. So here we go. Drum roll, perhaps. So what we are announcing, and I think this is appropriate given that today is Global Graph Celebration Day on Euler's birthday, the founder of graph theory, and we're announcing the Euler Idea Contest, which is what we're calling this hackathon that is starting April 27th and runs until June 4th. So this is the announcement and kind of time for registration for this hackathon. Let's talk a bit about what this is. So we talked about this really neat Neo4j GraphQL library that Dan and Daryl went through in a lot of detail. And we're really interested to see what the graph community can build using this Neo4j GraphQL integration. And so this hackathon is a chance for the community to explore some ideas maybe that you have for building an application, and really some incentive to see what the awesome community can build using this library and Neo4j, GraphQL, and of course other technologies. So like I said, now this contest is open for registration. We're using a site called DevPost, which is a site for kind of managing hackathons. If you participated in the last Neo4j hackathon that we did around nodes last year, or maybe the year before, you should see this similar platform. So it's now open now. You can go to that link and read in a lot more detail what this is all about. But basically starting April 27th, you'll be able to start submitting projects. So the idea is give folks time to work on these until June 4th, when we will then close submissions and do some evaluation. And then at Nodes, which is our online conference, the Neo4j Online Developer Expo and Summit, that is June 17th, we will be sharing the winners with the world to see the cool things that everyone has built. So as incentive for building cool things in this hackathon, the total prize pool is $10,000. So first place, and this is for if you submit as an individual or if you submit as a team, this is split across the team. But basically $3,500 for first prize, $2,500 for second, $1,500 third, and then we have some most creative and other categories as well. So lots of hopefully good motivation there to build interesting things. So the idea is, we really want folks to explore fun ideas. So a large part of the evaluation is looking at what are interesting things that you can come up with, how complex is it, and then the feasibility and completeness of your solution. So we'd like to see the code that you build for this, and also sort of a 2-minute pitch video walking us through your idea and what you had a chance to build. And this is all managed through that dev post link. And we want to make sure that everyone has resources to explore this new Neo4j GraphQL library and understand how this works with Neo4j, other technologies in the context of full stack application, and so on. So there'll be some resources that we'll be putting out at least by that April 27th deadline, if they're not out already. One of these will be a new course on Graph Academy showing how to build GraphQL APIs using the Neo4j GraphQL library. We'll have several demo apps that will be open and out on GitHub for you to use as kind of a starting point. And then if you are on the Neo4j Discord server, which of course everyone should join, but there is a special hackathon channel there where we can coordinate efforts around this hackathon. The other really exciting resource that will be exclusive to the hackathon participants is Aura free tier. So if you're familiar with Neo4j Aura, this is hosted Neo4j as a service, Neo4j in the cloud. And we announced a free tier a couple of months ago that is perpetually around. So these are Neo4j Aura instances that you can use for free, as the name implies. There's currently a wait list for that, but we'll be unlocking 100 slots for the first 100 hackathon participants. There is a separate form, so look in the dev post for the form to indicate that you would like access to Aura free tier, and we're giving out 100 Aura free tier slots to hackathon participants. So that should be a really great resource for developing and deploying your application to the cloud. So if you haven't done a hackathon before, a lot of times these are done in a rapid, compressed time frame, but we have a bit more time now. So the dev post goes into a bit more detail of kind of the process generally of how we can sort of plan our idea, coordinate, build a prototype, and just sort of keep in mind the various deadlines as you're going through that process. If you want to see kind of what the community and folks have done previously in previous Neo4j hackathons, I mentioned this one earlier, the global graph hack, and you can see what folks submitted, what ended up winning, to give you an idea of cool things that the community has done in the past. This is our judging panel. So some folks from Neo4j and from the community. So with that, like I said, the DevPost site is open now, and these links will be shared in the slides when we share those with everyone. But you can go to DevPost now. There's also a blog post that goes into a lot more detail on the Neo4j developer blog, and the timeline is up here now. So anyone can register now, and then the hackathon officially kicks off April 27th. Great, so that was our special announcement. And I think with the rest of the time, it'd be great if we can take everyone's questions and go from there.
Thank you very much. So that was a very exciting announcement, wasn't it? So everybody, if you've got questions, have you got a GraphQL specific question? Do you have a not so specific GraphQL question? If you've got questions about the hackathon, if you've got anything you can answer, put them in the chat now. So we are keeping an eye on the chat. You have this wonderful audience, this panel in front of you. So bring your questions and yeah, let's go through them. So I noticed there's a few questions that have come up, so I will start popping these through. So I'm going to start off with the first one that I spotted, which is here, and I've put it at the bottom of the screen. So we had one from Suka, which was asking, GraphQL is not the same as Cypher. So
I can take that one. No one else wants to jump on that. So that's right. GraphQL is not the same as Cypher, although they both do work with graphs, of course. So Cypher is this declarative pattern matching based language for working with graphs. We use this in Neo4j, but there are other implementations of Cypher in other graph projects. There's the Open Cypher standard, so it's not specific to just Neo4j. With GraphQL, GraphQL is very much a API query language. So GraphQL is about building this layer that sits between the client, like a web application or a mobile app, and sits between the client and the database. So with GraphQL, we are able to express what we think of as traversals through a data graph, but really in the context of interacting with an API. And so GraphQL lacks a lot of features that we would kind of expect from a database query language. Things like complex projections that we can do in Cypher. In Cypher, we can do lots of more complex graph things like variable length traversals and pattern matching and this kind of thing. So I think that Cypher we think of as a database query language. GraphQL think of as an API query language. That's how I think of it. I don't know if anyone else has other thoughts on that.
Cool, thank you. Next one up, we have got from Fountainhook. Is there a way for solo developers to find a team?
For the hackathon, yeah, I think probably the best resource here is going to be sharing in the hackathon channel on the Discord and also on the community forum. I think we have a section specific to projects. So maybe if you're looking to find a team, post in the hackathon channel on Discord. And if you have a specific idea, share some details of what you'd like to work on, and folks can chime in there. I think with a hackathon, it's always helpful, especially if you have an idea you want to work on and you kind of know what your skill set is, but you then sort of know kind of what you're missing. It's also helpful to share, here's my idea. I'm really good with maybe like back-end code, but I'm horrible at front-end design, and I'm really looking for someone to help with front-end design. Do you want to join my team and then work on this idea, or maybe we can iterate? So I think that's probably one thing that's really helpful when you're trying to form a team is to sort of share exactly what you have in mind and what you're looking for, so that folks can kind of select based on that.
Brilliant, thank you. Next one up from The Rob Brennan. Fun question. What excites you all the most with GraphQL Beta right now?
I'll jump in then. Hey Rob, it's good to hear from you. For me, this is like my first open source project that I've worked on, and we just open sourced last week. I think I lose track of time. It's really flying by. So I'm really personally excited to kind of see this grow, see the user base grow, start getting loads of good feedback in, seeing what people are building. For me, it's all about, that kind of natural growth that's going to occur from here on in. And I do think it's a really exciting product, and we're just kind of really stabilizing things now. It's feeling quite good.
I'll jump in. Hey everybody, the PM for product manager for GraphQL on the Neo4j side. What excites me the most about this project and this product is making sure that we can, as Neo4j, meet you where you are, what your skill set is. If you're a GraphQL developer and you love GraphQL and that's the most comfortable thing for you to work on, we want to provide you that capability. As much as we love Cypher and we want everyone to enjoy the benefits of Cypher and get to use the power of it, we also recognize not everyone has all the skill sets, right? And so the more we can make things available and approachable from a Neo4j standpoint, the more we want to make that happen.
Brilliant, thank you. Well, I know we've got a few more GraphQL people on here, so I'm expecting responses from all of you, because it did say all, so
yeah, maybe I can go then. I think on the personal level, it's how quick it is and easy it is to set up a fully fledged API that's protected with auth and everything. It's so fast to try out new stuff and prototype. That's what excites me the most at this point.
I'll chime in now and say about nested mutations. I hope that our slides today have proved how valuable they are, and they really excite me. You can create a whole subgraph within one GraphQL query, and ultimately that's one Cypher statement as well. So I'm really looking forward to seeing how people use that.
And for me, I'll kind of echo a bit what some folks have already said, but I think the auth model is really powerful, and setting up these authorization rules in an application, an API, can be kind of a pain. I mean, there are solutions out there to do this, but having this built in and being able to define authorization rules in your schema with GraphQL schema directives is, to Oscar's point, like a huge power up, and allows you to iterate really, really fast. So I think that's a huge win for developer productivity.
Fantastic. So we've got another question coming in. So, not quite. Maybe it's GraphQL. Oh, we'll see it is. I'm going to bring it up. We've got another question coming in. It's a bit of a big one. So, question around braces, brackets, and parentheses. Is there an order to use them? So I suspect some of this might be Cypher related as well. So.
Yeah, well, maybe we can talk about the Cypher case first, and then we can talk about where some of these come in with GraphQL, because yeah, this, at first glance, this all can be a little overwhelming, different syntax and whatnot. So first of all, speaking with Cypher, so Cypher is all about pattern matching, and we use these symbols that you're mentioning now to draw these sort of ASCII art representations of a graph pattern. So we define nodes within parentheses. So think of it as kind of like drawing a circle to represent a node. And then relationships are represented with square brackets and kind of an arrow with the carrots to kind of indicate which way the relationship is pointing. And we can string these things together to create more complex graph patterns. Then in Cypher, we use curly braces to indicate like an object for the properties, the attributes on either the node or relationship that we're talking about. So hopefully and if you look in the Neo4j developer guides, which we can link the Cypher page in a minute, you should see some examples of how we can build up those patterns. This I think is really, really useful because we are able to sort of explain just patterns, and we can use things like variable length pattern operation, and then it's up to the database to figure out how to go find and work with those. Because it's declarative, we don't have to explicitly say how we want to operate on that. So that's the aspect from Cypher, but someone else want to talk about some of those symbols and what they mean in GraphQL?
I was worried me and Dan were going to fight for it then. I think, yeah, to kind of focus on the point about is there an order of them, like using the curly braces at first and then parentheses last. It's just making sure that you're kind of opening and closing them in the same order. So if you've opened some parentheses at first, then some curly braces, make sure you're closing those curly braces before closing your outer parentheses. But in GraphQL, your curly braces are used to represent objects most of the time. So you're kind of saying that, a movie has a title and a release date. That's going to be inside your parentheses. Sorry, your curly braces. Now I'm getting them all confused. And then inside your parentheses, that's more like arguments for a query. So as you saw, we had like where, we had, create, connect. That's generally kind of saying like, I want to have a where clause, and then that where clause is going to be an object looking at certain things. I hope that helps a little bit.
Brilliant. Thank you very much. So we've got another question. So we're coming to time of this session. So we've got one question we're going to sneak in. And it's so apt. It's so apt for today. So key question here. What made you all fall in love with graphs and see problems in terms of graphs?
I'll start on this one. So one of the things that made me fall in love with graphs was the flexibility of returning things from the database. So beforehand, I came from a NoSQL world. I was using NoSQL databases, and it's very much you get a document and then you query for a document and you just get that document back. But with a graph, you can project this huge structure out of the graph. So for example, if you look at the GraphQL queries that we made today, we asked for movies and we also asked for the actors at the same time. And we can represent that and return that from the graph in a nice JSON structure. And when I realized that, I realized the power of a graph. And that's what made me fall in love with graphs.
Love it. Should I pick names? Anurag, I'm going to go in order around the screen. What made you fall in love with graphs?
So I came from a BI world where things were rows and columns, right? And coming to graphs basically had two realizations, right? One is that things are connected, and those relationships are important, and they're not necessarily very easily expressed through rows and columns. And then the second is that the real world is messy, where rows and columns make things, make you want to have to fit things into neat structures where those neat structures don't exist in real data. And graphs handle that very, very well by essentially storing efficiently what is there and not storing the stuff that's not there, and being able to traverse things the way you want to. So I think those are sort of the two things I'll mention.
Love it. What about yourself, Oscar?
Yeah, it fits my mental model better of how data is structured. Usually, I come from a SQL background, as with rows and tables, and being able to traverse the data like almost for free in real time is so much better than to doing large joins on tables to filter your data and stuff. That's why I love it, I think.
Brilliant. Daryl, you're next up.
Sure. Yeah, so I'm actually fairly new to graph databases. I only joined Neo4j in January, so it's all quite new to me. However, very familiar with GraphQL at this stage, and that all came from building GraphQL APIs around relational databases. And yeah, just so many issues with like, N+1 problems and things like that, which just made it so difficult. So this is a real breath of fresh air, like having graphs all the way down the stack now. But it just, I think, echoing kind of Anurag and Oscar's points, it's just the real world is messy. When we were using relational databases, we were just putting information in places where they didn't really fit because there was nowhere else to put them. And thinking in graphs is just so nice. This is why I love GraphQL, and it's why I love Neo4j as well. It's how you think about your data, and then it just maps perfectly into both of those things.
Brilliant. I guess it must be a real shock to the system to sort of go from the situation where I've got a table, right? How do I wrangle this to? Oh, I'll just take this object that kind of is the same shape as what I wanted to push out. Oh, thanks. Well, over to you.
Yeah, I think, again, echoing what Daryl was talking about, this idea of the intuitiveness, and to me, there's huge, we call it developer productivity, but it's basically reducing the overhead to answering questions, building applications. And it's interesting to Fountain Hook, who's asking this question and kind of mentioning that, not really having specific ideas and kind of, thinking that you need to have some domain thing that you're working on to apply problems. For me, my first exposure to Neo4j was actually at a hackathon, so maybe it's appropriate. We're just talking about announcing the hackathon. This was, I don't remember what year this was. It was right after Neo4j 2.0 was released. So browser was very new, and Cypher itself was very new, and I think adding node labels was also new in this release. And anyway, we're at this hackathon, and a friend and I were, we had no idea what to work on for this hackathon. It was kind of open-ended, and I think we looked on Hacker News, and there was the Neo4j 2.0 announcement is great for building recommendation systems. But okay, yeah, let's build a recommendation system. And so we were kind of trying to learn Cypher, and this idea of pattern matching, like in Cypher, just like clicked really, really early on. I think we had like a day and a half for the hackathon or something. And what we ended up building was a GitHub recommender system. So you would sign in with GitHub, and it would look at the repositories and sort of the tags, things, people that you're following. So GitHub has also this social component. And we would do this kind of graph traversal that says, okay, well, you've contributed or starred this repository. Someone else has worked on that repository. What else are they working on? We're going to recommend this as an interesting repository to you, kind of a bare bones sort of collaborative filtering traversal. And it was amazing to me that we were able to start with this new technology, that graphs and graph database are completely new to us, but in a day and a half, we built a working application, and we ended up winning the hackathon, which was fun. But I think from then on, I kind of, and to Fountain Hook's point of kind of domain and real world problems, kind of after that, I was kind of really hooked, and I worked for a few startups as a developer after this, and kind of everywhere I saw these graph problems was trying to introduce Neo4j for different use cases. So anyway, that's kind of my story and how I got hooked.
That's fantastic. Thank you so much, everybody. We are to time. We're a little bit over. I just saw a question comment. I thought it'd be brilliant, but the very quick response, Eunice, would be, it's pretty easy. We're going to put links to how to get started with graph databases and querying. We're going to have that in the video description, so please check it out. Give us an hour or so. We'll get those details up there. But other than that, thank you very much, everybody. So thank you to all of the guests today. So thank you very much to the GraphQL team. Thank you very much to our community members that came earlier. Alex and I are super grateful for all of you joining us. We hope you had a brilliant day. Thank you to everybody around the world who came in and joined us as part of Global Graph Celebration Day. It's been amazing. We've had people from all over the world. The shout outs were great fun. Thank you so much. Hopefully we have we celebrate and mark Global Graph Celebration next year in a better place than we are today, and the thoughts of everybody. And otherwise, thank you so much and see you all later. Bye.